we're on.
So here we go. We're going to step through the introduction to pacscan, just giving you some ideas of what this is all about. So basically, pacscan for us, it's a digital control network that we use for monitoring our actuators. By doing this, we're able to offload a lot of the processing from, let's say, your control system or your DCS system, and in essence give you what I would call like a remote I/O module or data concentrator that simply deals with valves, and it gives you information off of your valves. Okay, so we came up with pacscan to handle that whole situation. Okay, simplifies things in a lot of ways. Okay. Not only are we able to connect to our actuators, we're also able to tie in other field instruments to the pacscan system, and therefore your control system is able to get feedback from that. Okay, so this is basically how it's set up here. You're going to always have the operations area, operators sitting in front of their workstations, monitoring the plant. There's going to be some mode of communication in between. Just so happens that we're able to put our master station right here, so your DCS can communicate directly to that, and we handle all the valve stuff. Okay. If you didn't use a master station, you'd probably have a very large I/O cabinet with a lot of I/O modules to control a valve, and I'll get deeper into that shortly.
What communication protocol are you using to talk to all the actuators?
It's our own proprietary protocol. It's pacscan. Okay, it's a current-based protocol, so it's riding on about 27 milliamps or so. Okay, that's the carrier signal, and it's just some bits that are imposed onto that carrier signal that basically gather information from the actuators. So it's not like Modbus or anything. It would be similar to a Modbus or foundation field bus or something like that, except it's our own proprietary network that we came up with, back in the mid-'80s. I think Matt's here. Okay. All right. So the big question is why would anybody ever want to go do a digital control network rather than hardwiring an actuator back to your control system? Okay, there's a lot of reasons why you would want to go to a digital network. Okay, some people think, hey, that's just more stuff that I have to learn and everything like that. If it's hardwired, it's just going to work every time, and I know how to troubleshoot that. But there are lots of benefits to going to a two-wire control network such as pacscan. Okay. Basically, when we look at actuator sales, in general with Rotork, so because we're in the actuator business, right? So we pretty much, we can take a cross section of all of our customers to kind of see who's doing what. Okay, most people like non-network situations. Okay, most people don't want to deal with networks. It all really boils down to how deep do they want their maintenance folks to get into troubleshooting and doing stuff? What is the knowledge level of the people that are working on site? Okay, some people say, you don't want to deal with that. I don't have guys that are good at that. I don't want to work on that, so way out for that. So most customers don't go for the whole wire, the digital network. But of all of our customers, most of our customers go with pacscan, and everything else is a lot less. But we can do any protocol there is out there. Any protocol that's on the market right now, that's in the industry, we do them all. But most of what we sell is pacscan, because once we've sold them into the virtues of that system, people they like it. Okay, as long as you have the system set up properly with all the fundamentals in place, you typically don't have issues with the system. Okay. So the reason why you want to do this is because across two wires, you're able to get all of this information from an actuator. Your limit position, open, close, feedback. You can do modulating control with the actuator, ESD control. You guys familiar with ESD control or anything like that? Do you guys, okay, for instance, do you guys have like any valves in your system that if an emergency situation happens, that valve has to go closed, or that valve has to go open? Okay, that would be an ESD situation. So we're able to respond to a signal from your control system saying, hey, we have a problem, we have an emergency, this valve has to go open or it has to go closed.
Some of them are like spring loaded though.
Oh yeah, yeah.
That's where they're set up. It fails,
Set
it
up,
fails,
so
open.
they fail,
It
close,
fails,
fail.
close.
Yeah, so you have some pneumatic actuators out there that probably spring close, spring open, depending on what the situation is. Yeah. So like, let's say let's just say if you didn't have that, then obviously control system senses bad situation, sends a signal to the master station to send an ESD to a valve and tell it to go open. And then on another level, down at the actuator level, you can actually say, okay, I'm gonna go, you can tell the actuator to open or close no matter what. In other words, even if I'm seeing torque, even if my motor is overheating, no matter what, close this valve. In other words, bypass all your protections to close the valve. So on the actuator level, you can actually set it up to do that kind of stuff, okay? You can monitor continuous valve position. Is it available for control or not, local or remote? Is it in stop? Is the motor running? Torque switches trip? Is somebody actually spinning on the hand wheel? And there's probably 15 more different I/O points that you can pull from the actuator all across two wires. All across two wires, okay? So if you think about it in a standard control system, hardwired control system, how many wires would it take to pull all those signals back? Yeah. So you figure you're gonna need 2 wires for each of those, each signal, okay? And that extrapolates into, okay, the standard I/O module on a PLC has about 16 channels on it. Okay, so you might be able to cover an actuator and a half with one I/O module. Imagine if you had 20 actuators. Now you're buying more PLC modules. Now your cabinet gets a lot bigger, and now you're running wires. You can kind of start to see the benefits of kind of going to a 2-wire system. Okay.
Can you pull all the data out into our SCADA system?
Yes.
PacsCan?
Absolutely. Yeah, most people just pull in what they want to see. You know what I mean? 'Cause sometimes we put these, if it's a new system, you get a chance to kind of, work with the integrators, work with the operation folks. It's like, what do you want to see on your screens? What's beneficial for you to see on your screen? Okay. And with that, then you can just map out the alarms that you want and bring them into the control system. It's just mapping it and reading a memory location. But yeah, you get a lot more flexibility, when you're going with this type of system like this. Okay. So there's a picture that we took a long time ago at one facility. They were going the hardwired route. Okay. Now, not everybody's panels look like this. This is just an extreme. This is hopefully. You guys are laughing over there like, wait a minute, I've seen that panel before. Actually, it was here. No. This was taken over at a plant, and you can just see. Obviously, this is the worst case scenario, right? Okay. Let's just forget about like all the wires and I/O modules that they have in here and all the wires going everywhere, okay? When you go to the actuator side of it, look at how many wires you gotta pull into the actuator, okay? So, yeah, you have some breathing room in your panel to do whatever you want, even though you have a 1,000 modules just to, monitor a simple, filter system or something like that. But look at all the wires that you get pulled into the actuator on top of like the 480 volt power to power it up. You got to land all those wires to pull all those signals back. And you're at the mercy of the skills of the electrician who dressed those wires and, brought them into the actuator. Okay? And troubleshooting an actuator that isn't wired up cleanly can be a chore. Okay? That's the benefit of kind of having just 480 volt power and, 2 twisted shielded paired wires landing on some terminals in the actuator. It simplifies a lot of this stuff. Okay? So basically, the other thing is that we're able to, like you said, standardize on field connections and the integration of field devices. So you don't have all these different variations of where you got to land wires. If it's a modulating actuator, well then I have to know that I'm landing on 26 and 27 and 22 and 23, and I got 480 coming in here. And then all of the other feedback signals I want to get out of the actuator, okay, wired into that. This kind of just simplifies that whole situation. Just simplifies it a whole lot, okay? So yeah, this is your typical setup right here. From HMI to PLC and to out to your actuator, and each actuator has a point-to-point connection. Okay. What's not shown is that 8 pairs of wires coming in. Okay, that's your typical. And now, when you start talking about bus technology, this would be an example of maybe like a Modbus type network, or maybe Profibus or DeviceNet or something like that. Okay. So basically, you go out from the PLC, you daisy chain everything together, and you terminate at one end. Okay. Problem becomes something happens here, or something happens here. All of these guys are gone. They're gone. You, in effect, created an island of actuators that have no route to get back to the control system to report its feedback. And thus, your system is probably shut down at that point. Okay? So, while, yeah, you've got a little bit of savings in cabling and stuff like that, this is, and these are good networks, but like I said, you're at the mercy of how good somebody wired this up and how, things are routed and everything like that. Okay? So basically, those are your advantages. Okay? Cable cost reduction, installation and commissioning costs are reduced, engineering costs are reduced, maintenance costs are reduced, information available is increased, diagnostic data available is increased, and these types of systems are available for, as far as upgrading, adding to the systems. Let's just say you guys wanted to add, let's just say, I'm just going to give an example. You guys wanted to add a few more of your RO vessels, and you had probably 10 or 15 actuators that went along with them. You don't got to go buy a whole new pacscan system. All you need to do is patch those guys into your existing loop. That's it. Patch them in. You don't have to go invest in another whole bunch of I/O modules and stuff like that. You just get the actuators and run the wires to them and patch them in. It's like anything else.
Home runs? Every actuator needs to be home run, or they come back to the other?
Yeah. So basically, it goes out of the master station, tags actuator number 1, daisy chains through all the actuators, and then there's a return line going back to the master station. So it's just, and it's a loop.
The last one?
Mm-hmm. Comes all the way back to the master station. And that helps you out with that whole situation about creating an island when you break the loop. If you break the loop, you still have another route to communicate. So those guys that were supposedly should be gone, you got to come through the back door to talk to those guys, and they're still there. Okay. If you had to add actuators to the loop, all you need to do is find a good place to break the loop and route your cabling through those, and then reconnect your loop. So this is a diagram that shows you better. Yeah. This is a diagram that'll kind of show you the whole pacscan setup. Okay. So you got the master station, like I was saying, goes out, tags each, comes in, and then out of every actuator, and then goes back in.
So the breaks in the middle, now what?
So if I get a break right here,
Uh-huh.
I'm going to communicate this way, and I'm going to get that guy. Okay?
Conversely, the other way.
And exactly. So the master station's always going to want to communicate out of the A side all the way back to itself. Okay? If I break the loop, it senses, as soon as the loop is broken, it goes into a routine where it says, I'm in loop back. There's a problem. It sensed a drop in current, or whatever it is, okay? So it's basically gonna go through the routine of saying, okay, I can go this way. This is as far as I can see. And then it's gonna go out the B side and pick up all I can see. And then it's gonna come back and say, I have a break between address 3 and address 5. It'll tell you exactly where the break is. So you need to go there to go and assess the issue, okay? So it'll tell you exactly where things are happening, okay? So now this is the setup that you guys more than likely have. Now, your control systems guy, I forgot his name. I know he was working on getting Modbus TCP hooked up to your master station. Yes. David Charles, yes. Okay. So right now you have options for connecting to the master station. You can do Modbus over TCP, which is in essence just an Ethernet connection to the master station. Okay. Or you can do Modbus RTU. I think that's what you guys were doing before, like an RS-485 or an RS-232 connection to the master station. I think that when we did this last upgrade, David Charles wanted to get rid of the Modbus RTU setup and go to a Modbus TCP setup to the master station. So it's just a matter of him getting his module configured so that he can do it. But right now, I think it's working fine on Modbus RTU, but you'll have even faster response time from actuators and stuff like that if you went to a Modbus TCP type setup. Eventually, that's a really good type of setup. Okay, so but the master station gives you every option in the world, depending on whatever you have to connect up to it. Okay, so TCP or Modbus RTU, so that's RS-485 or it's RS-232. Okay, all right, and then so that's the control system side of it, and then down here is what we control, which is the loop, and we can do up to 240 actuators on one loop, up to 240. So what this is showing you right here is this is like normal operation, okay? And then what happens when you break the loop and what the master station is doing. So each of these represents an actuator, okay? So communication is always flowing through the actuators, always back and forth through the master station. It's constantly going through and it's asking every actuator, what's your status? Or here's a command for you. What's your status and here's a command. And that's happening very quickly, okay? And when it gets that information, it stuffs it into data registers, okay? That's there for the control system to read, okay? So we give you data registers that represent 50 different things going on with that actuator, okay? It's just up to you to decide what you want to pull out of the master station. But all of those registers are constantly being updated. And when you have a hot standby system, the guy that's in control, that's gathering all of the data from the loop, on the back plane is passing the information to the hot standby master station that is waiting to take control if some event were to take place and this guy was unable to handle the loop, okay? You guys have a hot standby system, several of them, I guess, at your facility, okay? So that means that this guy right here is running everything, but this guy is in hot standby waiting to take control of the loop if there's a problem, okay? Not only do you have redundant master stations, you also have redundant loop driver modules, okay? The piece that's actually driving the current loop, you have 2 of those also. So this guy is also just waiting to take care of things. If something happened with this loop driver module, this guy didn't say, hey, we have a problem over here, we can't handle it. I'm gonna let my backup partner take over. And that flip, when that switch happens, you guys won't even know it happened. There's no latency whatsoever. It's instantaneous. The feedback, when it goes from the A side to the B side, there's no delay in data, okay? So this is what we're looking at when it's working properly. Each actuator has 2 sets of relays in them. If you look at a pacscan board, there's 2 relays in it, okay? That's the A side relay and then the B side relay, the incoming and then the outgoing, okay? So, as long as everything is hunky-dory with an actuator, all those relays are gonna be open, okay? And current's gonna flow through and the signal's gonna flow through and you don't have any situation, okay? Now, what happens if you have a problem on the loop? Well, let's just say we had a short circuit, something took place, wire got cut, somebody with a backhoe dug up a conduit, something happened, okay? Well, we already know that a current source should only be coming, you should only have 1 current source ever, okay? You don't want to have 2 conflicting current sources, okay? So, these relays are always open, meaning that the current is flowing from this loop driver module all the way back to the master station always, okay? Each loop driver module actually has 2 current sources in it, the A side current source and the B side current source, okay? So, what happens when I break the loop? The master station senses a ripple in the force or something going on with current, okay? It goes into loopback routine. What it does then is it literally isolates the problem. It isolates the problem. So if I got current flowing this way, going through an actuator, and I'm in loopback, which means my B side current source is going to be coming this direction, you don't want to have 2 current sources meeting each other, ever. Yeah. So one of these relays closes right here, which in effect isolates it from the communication that's coming in this direction. And that's how it knows which MOV is where your problem is located. So it's going to give you the address on either side of the problem. Because now we have 2 isolated current sources now running automatically to keep your loop intact.
So when it happens, is there a display that tells you, hey, we're having an issue?
Yep.
What will we look for? What does it say?
Yes. You can do it one of 3 ways. One of 3 ways. One way would be if operations was pulling back the loopback alarm and then the 2 loopback addresses that the master station has ready, okay? Then they'd be able to, let's just say you had a diagnostic graphic over there, maybe in the maintenance shop, you guys had a workstation that had a diagnostic graphic, just saying, some people have it, okay? You guys be in there, oh, okay, we're in loopback, it's between MOV 2031 and MOV 2042, okay? Master station knows that because it knows the 2 addresses. You guys know them as tag numbers, okay? Or valve numbers, whatever the valve number is and whatever its function is. You could have it set up to tell you it's between this one and this one, okay? That's one way to do it, okay? Simpler way is walk up to the master station and go to the diagnostic screen. Go to the diagnostic screen on the master station and look at your loop diagnostics and it'll say, hey, I'm in loopback. I see 4 MOVs on the A side and I see 20 MOVs on the B side. Okay? Because
First you have to know how they're aligned, right?
exactly. And that's another thing that we should do for you guys is have a loop map. And the cool thing is, you can go and you hook up your laptop, or you can go into the master station right on the keypad. And that's the stuff I'm going to show you guys, okay? When we're doing our hands-on. The master station will build your loop map for you. It'll tell you who's wired to who. It'll tell you that address 1 is wired into address 4, let's say, for instance, okay? Or in your case, you guys have tag numbers in your master station. You'll know the order of the cabling in the master station. And that helps out with troubleshooting if you guys actually have a loop map, a physical loop map. And I'll show you some examples of some loop maps that I drew up for some other customers.
Did you have it done for you?
I don't think we've drawn it. Well, we haven't drawn one, but
There's one here.
there's an actual.
I think Art probably did a hand drawing.
There you go. Yeah, and from the master station, you can get that information. There is a page you can go onto, and you can go through the loop
Okay, so
positions.
that's the day how we do that?
Mhm. Absolutely.
Because sometimes you create which card is which.
Exactly. So this is where. Okay, so this is where the tag numbers that are being used in the control system, okay, or that your operations uses, tag numbers that are on your screens need to jive with the tag numbers that are in the master station. Okay, and I think we can have up to a 15-character word in there so that you can put a long tag number if you need to inside the master station. Okay, so that should jive with what operations sees, because you guys are gonna get the work order from them to go fix something, and they're just gonna tell you a tag number. It needs to jive with what's in the master station there. Okay, so you can get it from the keypad on the master station, your control system guys, the operations potentially could have a way of doing it also if they were pulling back the data, or if you hooked up a laptop to the master station, just into the diagnostic port there, you can pull up a little web browser that's on the master station, and it'll show you everything. Show you everything there. So 3 different ways to get the data. It's there, okay? More than likely, most practical, obviously, is just being able to go to the master station and go through the keypad and knowing how to go through it to get what you need out of it, okay? How to navigate the keypad, okay? Yeah, so this is just showing you, like I said, 2 different master stations, hot standby versus a single. This is what you guys have right here. Okay. Remember I said you got, basically, that's your CPU, that's your loop driver module, that's another CPU, and that's another loop driver module, okay? In this case, when you have a hot standby system, you wire into what we call the key switch module, okay? That allows you to go there and flip between the A or the B side master station. If you, for some reason, you wanted to like upload new firmware or do something like that, you would do it by isolating one, load it, and then isolate the other. You can flip back and forth between the 2. But you wire into the middle here, and from there, we're able to see both sides of it through the backplane. Okay, so both sides of the loop. So yeah, up to 240 devices. The loop distance, the maximum loop distance, 12.4 miles. Okay, so you can have a pretty extended loop. Okay. Automatic redundancy and loop back is there. It is a current loop, not a voltage loop. Current loops are less susceptible to noise. Okay. A voltage-based loop, like let's just say, or network, similar to, let's say, a Modbus, Profi bus, or something like that. Those are very specific voltages. Like Modbus is like, it fluctuates between 4 to 7 volts in that range. It just kind of raises and lowers between 4 to 7 volts DC. If you were to have an SCR motor, anything like that, running a pump, inducing noise on a Modbus loop, okay, and you're raising the voltage where I'm looking for 7 volts, now I'm getting like 20. Yeah, your loop is done. It's done, okay? Now, it can happen on a current-based loop also. It can also happen, but let's just say the worst case scenario would be that that portion of the loop that's being affected by that VFD noise or that SCR noise, what would happen is you would, in essence, create a loopback situation, right? Because remember I said, the master station senses the current in the loop, and when it senses a problem with the current, that's when it wants to go into loopback and do things. So what could happen is there could be so much noise being induced in one part of the loop that it goes in the loopback. Well, guess what? I'm going to communicate this way. I'm going to go as far as I can get, and I'm going to communicate that way and see as far as I can get. The one issue that you may encounter if noise ended up being an issue is that the ground zero for where that noise is being radiated, it could potentially take out one of those actuators. In other words, the actuator can't get its information out, but because the problem's not radiating, to other units, you may be okay. So it's going to communicate as far as it can, but it's not going to get to that part where the noise is. But guess what? It's going to tell you how far it can get, and if there's no obvious problem, and we know we have noise, then, hey, guess what? You know what? This segment of cable that's going from this MOV to this MOV, let's do a test, okay? I'm going to run a bypass, okay? This is when my guys will go and we'll get a roll of cable. We'll literally run some cable, attach it to the actuator, run it along the floor, and then attach to re-splice the loop together, taking it, bypassing all of that stuff. And if the loop comes back online, guess what? We've identified a problem area in our system, okay? Something is susceptible to noise. I've seen that before, and by running that bypass, it's like, okay, so now that we know what it is, we're just simply gonna reroute, just 2 sections of cable. And a lot of times it's just easy, just find a different route. Or sometimes it's easier to move the leads going to the pump and probably route them along a wall or whatever it is, and then you just kind of leave the network cabling in place. So either way, you want to kind of have some kind of separation.
Is there an isolation tip or at least 480 volts?
These actuators? Yeah, they can be 480 volts, they can be 120 volts, they can be 24 volt DC. So we have voltage up.
Between the communication and power.
Mm-hmm.
That person got water in the conduit or something.
Yeah.
Is it separate so it never get exposed to the digital signal?
Typically, you guys would be running your power and your network in 2 different sets of conduit.
Correct.
So in that instance, you may be safe. But what happens if your conduit's not sealed? This is another problem that I see sometimes. If your conduit's not sealed and you have heavy rain or you have a flood or something like that, and now water is able to get through the conduit fitting, the seal type fittings, into here, okay? So, depending on the water level, how far it gets up. The good thing is, when water gets in here on these actuators, if water gets in here, it's not getting in here, okay? It's gonna be isolated to the terminal area. Because there's a nice fat O-ring right in here that's gonna separate this terminal compartment from the electronics. Yeah, so this thing will fill up with water, okay? Okay, so water hits the 480, boom, it's gonna trip your breaker, okay? Or water's gonna get in here and it's going to short your network together. In other words, we got A coming in,
Something back to the network or 480, depending on how long it
Well-
took for it to trip.
well, let's just say the 480, if the 480 doesn't, if your breaker doesn't trip, okay, if your breaker doesn't trip, then you're gonna blow the FS1 fuse in the actuator link, okay? So in essence, there's not gonna be any more power coming in, there'll be power coming into the actuator, but there's no internal power in the actuator backfeeding anything, okay? But the only issue is that now you're shorting your network together, okay? Because you got A coming in, referencing a common, and you got B going out, referencing the same common. If those two come together, it's gonna cause a situation. But it'll probably be isolated to that actuator or somewhere in that area. And being able to get to that area to figure out where the problem is, if that's what it is. Typically what I've seen is you'll be having trouble in one area of the network. 5 actuators on one side of the network just keep going off. They're dropping offline, then they come back. And they drop offline, and then they come back. You get a loop back over here, and then it goes away. You get all this weird stuff happening, but it's isolated to one section of the network, okay? So using the diagnostics, we're able to get to that area, and we just systematically start where the problem is, going through these actuators. And then you'll stumble upon one actuator and you pull the terminal cover, and water comes spilling out of it. It's like, okay, dry it out, reset your loop, everything comes back online, fine. But you know, who knows how long the water's been in there, you got corrosion now, and you know, you got all this other kind of stuff happening. But we use the diagnostics a lot to get to the bottom of problems, okay? I mean, because really you want to get to the bottom of potential problems, okay? If you guys had a network that wasn't steady and that was unreliable and was kicking your system offline all the time, okay? And that's when we got to start using the diagnostics to figure out why it's happening, where it's happening, and getting to the root cause of the problem so then you can fix it, okay? If you guys figure out that, hey, guess what? We figured out that a lot of the conduit entries into the actuators aren't sealed properly. So, all right, we found water in one, so what do we do to prevent that? Seal them off. Done, okay? You're not gonna have that problem again. So use the system to kind of take you to an area, figure out what the problem is, and then address it, and it doesn't come back. You know what I mean? If you have noise, and we figure out where your noise source is, we fix it, and then you don't have to deal with it ever again. You know what I mean? So it's using the diagnostics to kind of help you.
So for the noise, we've noticed every time we start a VFD, the noise level jumps on a loop.
Okay.
So is there an acceptable noise limit we should look for when we scope a loop? Like anything over 8 volts peak or 10 volts?
It all depends on what your loop current is set to now, okay? There is an acceptable amount of noise. The network will, surprisingly enough, it will power through. As long as the waveform doesn't get screwed up, as long as our signal doesn't get screwed up, we're fine, okay? But I know that Gordon, when he was out here, he did take some measurements and sent us a bunch of snapshots. And it was very obvious that, yes, when you guys were going through that startup, we would see the noise on your loop go up, but it wasn't so bad that it took things off of line, okay? But if you had water in the conduit on top of that noise, you know, maybe you create a whole different situation. Best case scenario is if you guys know that that's the case, and you do have that type of noise, when things start up, to me, I try to address that problem. You know what I mean? Figure out how we could, you know, obviously conduit's already run and everything like that, but if there's a way, you might want to think about possible rerouting. You know what I mean? That's the easiest way to take care of that problem, okay? But if it's not causing you any issue, then probably it's okay. But just know that other factors can contribute to it going south. So it would probably be a good idea if it's a known situation to probably address it. or you could potentially run into a problem.
These
Okay.
are all the questions that I've heard,
Mm-hmm.
you know, from Art,
Right.
you know, water and the actuator. I think they're ready to do the communication tables now or something.
Yeah. Easy. All those things help because I mean I know Art's been through it, you know, with that system over there, and you know, it's one of those things where a couple of things you guys have upgraded a lot. There he is. There you go. There. James. All right. Okay. Oh, there's the donuts. Yeah. Okay. So after I get done, after I get done with this PowerPoint, you guys take a little break, and then we'll continue on. Okay. So this is a picture of some of the diagnostic stuff that you can do with a laptop and plugging into your master station. Okay. Remember I was telling you about the screen that you could go to that tells you about where your problems are, right? So like for instance, I'm supposed to have 14 MOVs on my network, okay? It's gonna say, how many actual FCUs, field control units, or MOVs, how many did I find, okay? In this case, it says, I only found 7. So you already know you have a problem, okay? You already know you have a problem, okay? Last network reset initialized by what? What was the last thing that took place on the master station? What was the last thing that happened, okay?
Okay,
Mhm.
before we continue with this.
Yes.
Art has any computer with that?
You can use any computer because there's
So
no,
where do you get that?
there's no software.
No.
No. The master station has a web browser built into it. So all you need to do is you need a laptop with an Ethernet cable. You plug in, you put in the IP address up in your web browser of the master station, and these screens come up. Boom.
Can you bring a computer and do that?
Yeah, absolutely. You can do it on this guy right here.
What you need is the
That's only
IP
on
address.
3, right?
It's on the P3s, yes.
That's all, when you need the IP address?
You need the IP address and the subnet mask of the, and that's it. You put it up in the web browser, and then these wonderful diagnostic screens come up. Now, here's another thing I could throw at you guys too, okay? Depending on how you guys have your network set up, meaning your, let's just say David Charles wants to do Ethernet to communicate to these things, right? A Modbus over TCP. The reality is you could hook up a master station into your plant network, okay? As long as you have a path to get to this master station. For instance, if you guys had a master station in the plant right over here, and you were able to get it plugged into your network, I would be able to get on this computer right here, let's just say if we're all on the same network, and pull up the IP address of that master station and see diagnostics. In other words, if you guys had a workstation over in your maintenance area, maybe, and it was networked to communicate to the master station to grab these diagnostic pages, then you guys would be able to kind of look through and see what problems were before you actually went out there to deal with them. Just a thought. Some people do it, so it's not outside of the reach to do something like that, okay? So you can see it's telling you, hey, we had a fault on the outward wire, okay? And it's also going to tell you what type of fault. It's going to tell you it has an open circuit. This thing knows the difference between an open circuit and a short circuit on the loop. It'll tell you. If you have an open, just know that there's a wire that's been cut somewhere, or the wires have been lifted off an actuator or just hanging free, okay? A short circuit meaning the A and the B outgoing cables have been shorted together, okay? You can also duplicate that by doing reverse polarity, okay? If you know all of your wiring is perfect, you guys installed a new actuator. Let's say you took an actuator out for maintenance or something, okay? And then put it back in service and re-landed the wires to it, and you reset your loop and you got a short circuit. Well, that doesn't mean that you guys shorted anything out. It means that you probably have reverse polarity. Simple fix. Cross the polarity, reset the loop again, it goes away, okay? If it's a legitimate short circuit, then it won't go away, okay? So,
Will that car ever give you an open short circuit indication?
an open circuit, there would have had to been some significant damage to that card. In other words,
So under a normal fault.
under normal conditions, that would never happen. That's not the mode, that's not the way they fail, okay? For in an open circuit. Short circuit, I've seen it. I've seen that with a bad card, okay? But yeah, and that's always, and that could be because the relays aren't opening and closing anymore. I mean, it's just, or you got relays chattering, you know? Or I've seen if the network was hit with some transient voltage, somebody accidentally, hit the one of the network leads on some 120 or one phase of 480. That's going to travel down the network, and it's going to tag that card in the actuator upstream, and you know what I mean. And the good thing is, the card is going to fail in a way where it's not going to continue to keep going down. It's like you have 480 on the loop. Potentially, you can have it deadhead at one actuator and stop, okay? Because it's going to open relays, whatever. But if some one-off chance of a failure where it can just keep traveling down the network and just keep blowing cards as it goes down the line, okay? But that's only if you're just not practicing safe electrical practices, you know what I mean? Sometimes you have to have the actuator wired up to troubleshoot. Powered up to troubleshoot. It's just a reality, okay? Sometimes I may want to be connecting into the actuator with a tester to make sure that the A side and the B side communicate, okay? So you gotta have it powered up to do this. So you just gotta be very careful, that's all. Make sure that the little flash cards that are in these actuators are always in place.
I can open it.
Actually brought a few tools. That's pretty much the only tool you'll ever need right there.
My number 6, Allen.
Number 6 Allen wrench. Okay. So on top of that, remember I was telling you about your loop map? Okay, how this thing maps it out for you? Okay. So there you have it. So obviously you can tag these things out to what you want them to be. Okay, I just came up with some tagging. It tells you what type of actuator it is. Is it an IQ or is it an IQT actuator? Okay. It tells you the address of the actuator, and it tells you what position in the loop it is. Right there. So I can take all this information and I can go ahead and develop a loop map. Just based on looking at this one diagnostic page. I know who's wired to who. And it's also telling me that I have an issue between positions 2 and 3. Right there. It tells you, highlights and tells you exactly where it's at. Okay, so that's a pretty cool diagnostic feature of your new master station. Okay, very good diagnostic feature. Okay. Yeah, this is just more. This is more telling you, okay, depending on the number of field units that you have, okay, how fast can you expect to see information back to your control system based on the baud rate of the loop? Okay, in other words, how fast is the master station communicating to the loop? Okay, and if you have 60 field units and you're communicating at 2400 baud, then I would expect to have information back within 2 seconds. Okay, if it's 1200 baud It's going to be, somewhere around, 4-ish, 5-ish seconds, okay? So the speed that you're communicating on your loop side of it, from the master station to the MOVs, has an effect on how fast you can get the information back from the loop. Another cool feature of the master station is, let's just say you're running at a slow speed, right? You can actually have the master station test itself out by doubling its speed. So let's just say you guys are running at 1200 and you wanted to see, was our loop stable enough for us to go to 2400? In other words, double the speed of feedback, okay? You just turn on the loop doubling feature, okay? And what it'll do is it will increase the speed of your loop by a factor of 2. And then, as long as the loop integrity stays intact, it will stay at 2400 baud. But the minute something happens on your loop, it'll revert back to 1200, let's just say, okay? So, if you guys turn the doubling on, and you check it a month later, and the doubling's still on, and maybe another month later is doubling still on, then hey, guess what? Let's go ahead and just update everything and just have it be 2400. You know what I mean? And then maybe you can double again. You know what I mean? So you can kind of do stuff like that. But that feature only works if you have impeccable loop integrity. So if you turn doubling on and then within five minutes it goes back, that's already telling you that you might have a marginal loop. You might have a marginal loop, and there's something going on out there. Okay. This is more David Charles stuff, information that's probably beneficial to him, but commands have priority, okay? And what that means is that when the control system is requesting a move for a valve, requesting a move, go open, go close, go to 40%, go to 20%, whatever you're doing, modulating, throttling, or if you're just doing standard open close control, okay? Every time the master station receives one of those calls from the control system, it is going to stop what it's doing and process the command, because commands take priority. It's kind of like it's a master-slave relationship. It's like, open that valve. Okay, wait, all right, I'll open the valve. Or I'll close that valve for you. I'm gonna stop everything I'm doing to respond to the command, okay? So commands have priority. If you're modulating a valve and you're constantly positioning it, telling it to go 30%, 35%, 32%, 34%, it's on a PID loop and it's just trying to track and keep a flow or something like that, okay? Depending on how you're writing, the potential exists that if you have like multiple valves and you're modulating like 4 or 5 different valves all at the same time on one loop, your feedback speed is going to decrease by a small factor, because it's spending more time processing commands than it is giving you information. In other words, it's the control system is talking more than it's listening, okay? The master station is doing the same thing. It's like, I'm processing commands. I'll give you your read data because that's my second priority. I'll let you know what position that valve's in, type of thing. So that's one thing that that needs to always be looked at. I don't think you guys have the problem here, but like I said, that's more of a thing that your David Charles guy, that's kind of stuff that he can adjust in the control system to, you know, make it so you guys have the proper feedback in the time that you need it. Okay? So, just so you know that anytime a company goes to sell you their proprietary protocol, their proprietary information, it's like, okay, what is this, the new hottest thing that you guys have? And okay, you're trying to lock us into your actuators and all that, but this technology has been in existence since the mid-'80s. So this isn't like some new technology that Rotor just stumbled upon, okay? Rotor back in the early 80s actually bought the company that actually was using this technology. you know, I guess they were using it in like, you know, systems like in automobiles and in airplanes, kind of like, you know, like that, like CAN bus technology that you have in your cars these days. Okay, where every single instrument, every single thing in your car is communicating back to the main computer. In an airplane, every single device and instrument in an airplane is all communicating back to the main computer. Okay, every single thing has an address. If you remove some module from your car, if you ran the diagnostics on it, it would tell you exactly, hey, somebody took the left front door automatic window switch out, and it's not there anymore. It'll tell you, okay? It's the same kind of situation with pacscan, okay? Every actuator has a unique address, and the master station is gathering all this information from it, and it's being stored. So this is not old technology. This is not new technology for us. This is something that's been tried and true and tested, you know, way back in the mid-'80s. They say hundreds of systems controlling thousands of actuators worldwide. I think it's more than hundreds at this point. It's thousands of systems we have. Secure, mature communication. Okay. Proven interface with major close suppliers. Yeah, we have a lot of drivers that are available for like bigger DCS systems like Honeywell and stuff like that. They have a different flavor of Modbus that they do. We're able to do that for them, okay? We can easily scale this up and scale it down depending on whatever your situation is and create custom stuff for your situation, okay? And it's available for all of our actuators and even non-Rotork stuff, okay? Like I was saying, remember I was saying that with the pacscan network, you also have the ability to talk to non-Rotork devices or field instruments and stuff like that. Okay, so we have this thing called a general purpose field unit, which is basically like a remote I/O module. It has like 16 digital inputs. It has 8 digital outputs. It has 4 analog inputs and 4 analog outputs. Okay, so what happens if I have a flow transmitter or something like that? Or you know what? I want to sense pressure right over here near this MOV. I just need to for whatever the reason is. If you had one of those general purpose field units, or if you wanted to wire that into the actuator and not have to run a home run all the way back to the control system, you get one of these general purpose field units and you patch that into your network. Okay, so basically you have a transmitter out there that's putting out 4 to 20. Okay, you wire it into the general purpose field unit, and all you simply do is create an I/O point in your control system to monitor that analog data from that instrument. You don't have to run wires all the way back to the control system. It becomes part of the network, in essence. So it's one of those things. Is it something people are after? Well, it depends on how remote the site is and the ability to get wiring back to the control system. Okay, sometimes you got MOV out there, but you don't have you don't want to run, 1,000 feet of cable all the way back to the control house. Nope. You can just patch one of those things into the network and wire into that and get it back the same way. Okay, so that capability exists. Okay. So, what are the pros and cons? Systems. Okay. Well, let's see here. The pros, open systems, pros and cons, okay? So open systems are stuff like, take a break?
Yeah.
All right, let's take a break before we go into, actually, yeah, I was just about at the end of this one. So, are you guys ready to resume?
Yes.
I want to get us through all of this PowerPoint stuff so you guys can get some visuals on what's going on, and then we're going to go on to some good hands-on stuff, okay? I'm going to bore you just a little bit more with some of this stuff, okay? And also, I will be giving everybody a thumb drive. That's the other thing, man.
In the thumb drive, you have that presentation?
I've got this, and I've got all of the documentation, the tech manuals, the quick the quick start manuals for getting through the menus on the master station, how to get your laptop configured to everything.
Do you have both our master stations on the?
I will have everything, because you guys still have a 2E, don't you? Yes, absolutely. I will put the 2E data on there also. It's good information to have. All right. And we'll actually talk a little bit about the 2E in this part of it, just a little bit. Okay. All right. So here I'm gonna get. Okay, so we're ready?
I'm going already.
Okay, good. All right. Okay. So we're going to talk about the different types of field units, different types of master stations, different methods to configure the master station, and then more information about the physical network layer, test tools, and auxiliary masking. Okay. I'm not sure of how much auxiliary masking is being used on your site, but when I get to it, we'll know. Okay. So basically the FCU, we call it Field Control Unit, in essence is the pacscan card that's in the actuator, the communications board, the NIC card, however you want to call it. That is the board that we install in the actuator. Like I said, it's supported by all of our different product lines. Okay, that card can be used in pretty much any of our products. Only thing is the AQ version of it is slightly different. It's a slightly different board. I don't know how many AQs you guys have left, but fewer and fewer. Yeah. Okay. Yeah. So that's the communication board. Okay. So that's going to come with every one of your pacscan actuators, and probably that would be the board that you keep in stock as spares. You know what I mean? Hot spares if you needed one. Okay. The older style A-range actuators, the actual field control unit was housed in the terminal compartment. In other words, they gave you like an extra deep terminal compartment, and the card was actually mounted in that. Okay. So I don't think you guys have any A-range out here. I think the oldest actuator you guys have are the Mark 1s, the IQ Mark 1 actuators, and the AQs. Those are the oldest units, okay? And the only method you could use to configure those was using a pack tester. Basically, a pack tester is just a little handheld device that allows you to configure or do some type of network troubleshooting, okay? Like I was saying with the FCU, you do have the option to add transmitters or literally wire transmitters into the actuator. Okay? Providing analog feedback to the control house. Okay? That's just an option. We also have that general purpose field unit. That's kind of what it looks like. That's not a really good picture. But that is what it looks like. It's kind of like a little mini remote I/O module. Okay. We also have a rack mountable version of it that you can wire stuff into. Okay. For instance, if you guys had some limit torque actuators out there, or some ALMAs somewhere in your facility, okay, or some EIMs, and for some reason you guys wanted to bring those onto the pacscan loop to get all kinds of good data from them. Well, if you got a general purpose field unit, you wire that actuator into that and you put it on the loop. Done. Okay? So we don't discriminate, and that's how we do that, okay, with the general purpose field unit. We can literally wire someone else's actuator into our, and get it into our loop, and we can give the feedback to the master station. Okay? This is another form of master station. It's the 2S master station. Basically, it's obsolete at this point, but it's just a wall-mounted master station, no redundancy, and it had a membrane type of a keypad. Had the same LCD screen as you see on your 2E master stations. Okay, but that's, you know, it's all but obsolete. Or if you do have one, Those who do have them, they're like gold, because if a customer wants that, that's, you know, other than upgrading to like a single P3 or something like that. Yeah, that is just a smaller unit for a system. Has all the same functionality of the 2E master station, just that there's no redundancy whatsoever. Okay. Then there's the 2E master station, what you guys also have at some of your facilities. Okay. It's same as the P3, where you can control up to 240 devices. You can do a single or hot standby setup, similar to the P3. All of the host communications are pretty much the same, and we were even in the later runs of those able to make those communicate via Ethernet, Modbus TCP, similar to the P3. Okay. The only thing and with the Ethernet interface, you were able to have a web browser-like interface to go into the 2E master station and, you know, do some diagnostics. The diagnostics it's not as thorough as the P3's diagnostics, but at least you would be able to see the status of all your MOVs and if you had a loop back and stuff like that. But all of the bells and whistles aren't there. So that is a feature that was introduced into the 2E in the later days. Okay. And now the P3, which is what you guys have. So you guys have a combo. You guys have some of these, okay? And you guys have this now, okay? So this is just basically showing you the benefits of it and some of the new features that we created on this thing, which is.
Yeah, you said you had the other one, you had this one. It's just two separate entities. This was controlling this section, and the new was controlling another section of the plant, correct?
I believe that's it, yeah. Yeah, so I mean, at this point, it's one of those things where you guys because your 2E is working fine, there just hasn't been a need to upgrade, you know? Obviously, to get the new features and to be able to do the Modbus TCP and the diagnostics, whereas you didn't really have, there was diagnostics on the 2E, okay? But diagnostics weren't as good as you have on the P3 as far as fault finding, okay? It would still tell you that you were in loopback or that you had an open circuit or a short circuit, and where it would tell you the two addresses where you had a problem, but you just maneuvering through the keypad to find all the information was you just had to know where to go to get the information, okay?
How is the 2E going to be supported?
I think it's still supported with parts at this point. You can still get power supplies. I don't think you can get the CPUs anymore, okay? We do have, in Petaluma, I probably have upwards of probably 15 different, 15 2E CPUs. Basically, what we do is we get them refurbed, okay? Because the boards and stuff like that just aren't made anymore, okay? The power supply is the only thing that you can still get for the most part. Everything else is pretty much just refurbed, you know what I mean, for the most part. But yeah, we have some stock on hand, but it's one of those things, there's gonna be a point where it's just not gonna be there anymore, okay? I think that Rotork thing is, after something goes obsolete, we will support it for 10 or 11 years after it goes completely obsolete, or until stock runs out. You know, because a lot of times the technology changes and you just can't get certain chips anymore, ICs anymore, so, you know, it's one of those things 10 years is usually right around what we do. So this is the kind of a roadmap. Can you guys see this? Hold on a sec. Let me blow this up a little bit. Actually, but you guys, good thing is you guys are going to be able to play with it right over here. Okay. Let me blow this up a little bit.
You probably can see
Yeah, that's why I was asking. Yeah. Okay. All right. So this is kind of the roadmap inside the P3 master station. Okay. So you always start out with your main screen right here. Okay. So you have the choice to go to Diagnostics, see what's going on with the MOVs, the FCU menu, or Settings. Okay. You also get a view of the status of your overall network right here, or your overall system. You can see field network status. If you see an X through that, you know that there's an issue out there already. Without even going into any diagnostics, you already know that there's probably an issue out in the loop. And that could be as simple as somebody has an MOV in local, or there's an MOV that's been powered down. See, that master station doesn't discriminate. It simply says that, look, if you're in local, you can't control it from your DCS or from your PLC. Okay, so that's something you need to know about, that the operations needs to know that they can't control this valve. So this is an alarm. Okay, if it's powered down, it's a comm fail. Guess what? You can't control it, so that's an alarm. You walk up to this master station and you'll already know that something is offline or something is going on the loop. And when you probe deeper, you can actually find out what the problem actually is. Okay, so that's your main menu. Field unit comms check. If you have a check there, that means that it's communicating to all the MOVs. But if you have and field unit status, that means that there's not one alarm on any of your MOVs. But the minute I flip one into local, I'm going to get an X right there. Okay, so you should be happy that you're talking to all of them, but one of my MOVs, if you see an X here, there's something going on. And it may or may not be a real issue, but it's worth looking into, right? Okay, so the next screen, if I clicked on here, FCU screen, I'd get over to the field units, okay? And usually it pops up at the first MOV on the loop. Not the first MOV on the loop, address number 1, okay? And it gives you just the overall, this is the overall page on this MOV, okay? So it'll give you its status, it'll give you the tag number, okay? The type of network it's on, it's obviously pacscan 2, all right? So I'm able to go in and I can either look at the alarms, like right here. I can look at status of the MOV by clicking on this one. So it's open, I have a limit switch open, it's at 100% position, okay? And that's the only thing that's going on with it. It's not in loopback, it's not that it's in local or anything like that. Everything's fine with this, okay? If I wanted to control the MOV, I'd be clicking on the little actuator with a hand on it, and this is what it would take me down to right here. I can open the valve, I can close the valve, I can stop it in mid-travel, I can issue an ESD to it, okay? Or I can give it a set point or a position to go to, okay? Now, more than likely, if you guys try to do that from the front panel of the master station, the minute you're going to give it a set point, you're going to tell it, hey, go to 35% open, or go open or go close. It's going to go open or go close, and then the minute it finishes doing that, it's going to go right back to where it was before. Why? Because more than likely, your control system is giving it a command. So your control system command will say, nope, that's not where I want it to be, but this is just for diagnostic purposes, just to prove that the actuator is available for control. It'll let you give it a set point or control it, but the DCS command will override what you're doing and send it back to where it needs to go. That tells you that you're communicating with the DCS 1, and it tells you that the actuator is available for remote control. Okay? If it can run from if you can run an actuator from the master station, there's not a problem. If you can run the actuator from the master station, but you can't run it from the DCS, the problem is between the DCS and the master station, okay? So that's one thing. You guys go and you guys, you know, talk to ops. We can't move it. The valve is stuck. It's not moving. It's not responding to my command. Like, okay. First thing I do is I go to the master station. I look and see what's going on with it. Maybe there's an alarm. That's preventing them from moving. Maybe it torqued out. Maybe it torqued out. Maybe somebody left it in local. Who knows? But if you're able to pull up that screen and hit open or close, and it starts traveling open or close, and DCS isn't seeing it, then you gotta assume that there's something going on between the DCS and the master station. And usually that's the mapping of Modbus data. Something happened there. Okay. It's odd occurrence, but it does happen. It does happen. Okay. Yeah, so that's your diagnostics. Diagnostics for on the MOV level, and this is your ability to control, okay? There's other things. You can look at the parameters, the parameter settings of the MOV. You can look at alarm settings, and you could also look at a torque profile of an MOV from this front panel. So you can see how it's running as far as torque is concerned. It'll give you going open, this is what torque looks like. Going closed, this is what it looks like, and it just graphs it out for you. So you can kind of see, hey, this actuator always, when we start this process, we try to open this valve, it always torques out at a certain percentage every single time. Well, we'll be able to see that right there, okay? And now we know we have to address the issue, but we actually be able to see when it's happening and how it's happening.
Is that an average?
Yes, yep. Mm-hmm. Yeah, so that's all, that's good information right there, okay? Good information, okay? Hot standby master station, like I said, this is what you guys have, okay? You have the ability to communicate to it with redundant controllers, if you have them, or a single controller. All that functionality is in there, okay? Is, you know, as far as redundancy on the host side of things, okay? And yeah, so there's a lot of different different scenarios, you know, on the control side that you can do with this thing. Some people have a primary and a secondary controller in their control system. So if something happened on the control side, okay, they still have a backup controller to communicate to the master station, okay? We can handle that situation as well. You know, and be able to accept information from one or two different controllers, okay? The P3F master station is for one of those set it and forget it type of situations. It's a low cost. This is your entry level master station. If you're not interested in having any bells and whistles, and you just want to have a pacscan controller that's out there controlling some actuators that are in some remote location, that's the one right there, okay? The only thing that that doesn't have, for the most part, is a keypad and an LCD. But the web browser interface is fully, it's there. So you can buy that master station, and maybe somebody, in some cases I've seen where they'll buy that master station and come up with their own panel view touchscreen interface, you know what I mean? And build a graphic and simply pull back all the data into this graphic and have that be there to control valves. That's their interface into the master station. And they can get into the web browser and do what they want. But that's, you know, I don't care about your HMI, I got my own HMI, in other words, type of thing. So that's your bare bones master station right there, okay? So different modes of communication or configuration of a given actuator. That would be one, via the laptop, using infrared, or with our new IQ Mark III actuators, Bluetooth. Using our software that's free, downloaded from our website. Now this is configuring the actuators. This isn't configuring master station, this is actuators, okay? So this is one mode, which is a laptop and software. Mode number 2 would be the setting tool. You guys have seen these blue remotes probably around your facility? Yeah? Nope?
Yeah.
Okay, there's that, where you can go through and you can page through the settings and set up the actuator, set the address and all that. I actually have a setting tool here. When we go to the hands-on portion of it, you guys will go through and set up addresses and stuff in these actuators, so you can see how that's all done. Okay, or if you had a PDA, like a Pocket PC. Okay, Pocket PC. PDA with Windows Mobile 5 or 6 on it. We have a Pocket version of our software. And it also must have an infrared port on it also. Okay. Do you have yours with you?
Yeah, I have it in the car.
Yeah, sure. Just so.
I'll bring it in.
Yeah, cool. Pocket PC, where you can extract settings from the actuator, make all your changes, and upload them to the actuator. Done. Handheld device. It's small, compact.
Set limits.
Set the limits. Yeah. So that's also a cool feature. And that's all for setting the actuator up. So like with pacscan, the only thing you're setting up in an actuator is the address and the baud rate. That's it.
You could do any masking codes like push button station.
Yeah. So masking codes, that's another whole situation. Like it showed up in the beginning. If you guys had like a remote push button panel, and you could switch that panel into local and remote, and open and close a valve. Okay. If you had a control panel, okay, or you had an actuator that was up in the rafters somewhere that you couldn't get to, and there's a push button station down below where you can control it. That's where masking codes come into play. Because how does the actuator know the difference between it getting a command via pacscan or getting a command via push buttons? There has to be something that tells the actuator that I'm going to get it from here, I'm getting it from there. Okay. When you set masking codes in the actuator, we're monitoring that local remote switch on your control panel or in computer local switch on your control panel to tell the actuator, hey, don't pay attention to pacscan, pay attention to these push buttons, or okay, now you're back paying attention to pacscan to get your commands, because the actuator itself always stays in remote. Okay, so there has to be some way for it to know where it's getting its commands from, and masking codes is the way that's done. Okay. Configuration methods for our older product, like the AQ or the A ranges or pneumatic stuff, would be the pack tester. That's the only method to configure those, is the pack tester, because there's no nice LCD screen and infrared interface to communicate with those. So you have to literally hook up on the loop where your loop connections would go, and you would send configuration data to the actuator. Okay. A little bit more intrusive, I would say, as far as configuration, because now you got to take it off the loop and do all this other stuff to configure the actuators. Okay. But that's all for our older product. So there's also some actuator parameters that you can get from the master station. Okay, so on top of the stuff that I'm going to do with my setting tool or my PC or my Pocket PC, my PDA, the master station allows you to view parameters from a specific actuator also. You don't have that many parameters to play around with, but let's just say if it's a modulating valve and you want to change the deadband setting, let's say your when these actuators come out of the box, the deadband is usually at 5%. Sometimes 5% isn't good enough for the type of control that you want to do. You may want to go down to 1% or less. Well, that's one of the parameters that we can allow you to change from the master station. Okay? So these are the ones. The actuator type, you can put a tag name in here for that actuator. Max position, minimum position, 0 to 100%. You can set up an actuator so that If you don't want its end of travel to be 100% open, and you want it to be more like 75%, it'll do that also. So let's just say you give it a full open command, it won't go fully open, it'll go to 75%. Because maybe that's a valve you don't want to go open all the way, or maybe there's a valve you don't want to ever shut all the way. So you can kind of fine tune some of this stuff right here, like the max and minimum position. Right now it's set up for 0 to 100%, that's what most actuators are set for. But there's always that one-off weird valve in some places that valve can never go shut all the way. It needs to stay at least 10% open or something like that. So you can go ahead and short stroke that valve and set a minimum position here for that valve, okay? Auxiliary masking code, that's in there. Valve travel time, torque deviation, torque timeout. If you are monitoring real-time torque from the actuator back to your control system, how often do I want that torque to be updating the system? Do I want to see like real time? Do I really want to see, if I'm looking at it like on a bar graph or something like that, do I want to see it rising and lowering as the actuator is moving? How fast do you want it to feedback? Or do you just want a periodic snapshot of torque? You can set the timing right here for that. Okay. So that's just the few parameters that you can set from the web browser interface. Okay. We've already went through this, which is the physical loop and the loop back feature, but this is going to kind of go a little bit more into depth on this. All right. Physical layer. Okay, from the if you're looking at how things are wired from the master station to the MOV, I'm going to blow this up a little bit so you can actually see it. Okay, so basically this is like a block diagram schematic of your master station. This could be the 2E master station, this could be the P3 master station. Guess what? It's kind of basically the same. The only thing that really changes here is the numbering, but this is just for just visual purposes so you can kind of see, okay? So there's always an A in and an A out, and a B in and a B out. Remember I told you it goes out and comes all the way back in, right? Okay. So this is showing it goes out and then into A of the first actuator. So that's your first set of cables going to A and common. And then you've got another set of cables going out to the next actuator that also references the same common and then goes to B. So the reality is you really have a total of 3 connections, or actually 2 connections that you need to be concerned with because the commons are tied together, right? The commons are tied together on terminal 28. The A incoming wire comes into 26 and the outgoing wire goes to 27. So really, once everything's wired up, you really only have to worry about 26 and 27, the A and the B. But if you cross them, it's a short circuit. Okay? Okay, that's an easy way to kind of see how it goes. All right, because usually they have these put together under one ring lug and have them landed here on 28, which is kind of the preferred method. That way you don't have, you really only got 2 wires to deal with. Okay. So as long as you keep everything in the sequence, B always goes to A, B always goes to A, and then you go all the way back out. You're in good shape. Okay.
So then if you suspect a problem, like say with the first actuator coming out of port A,
Yep.
you would check to see if you have 24 volts on A and C. So you verify 24 volts coming in, but if you don't see anything coming out C and B, then you can say you have a problem with the board.
That would be one way to look at it. You don't have to measure, you wouldn't even have to go as far as measuring voltage, okay? Because it's already going to tell you. If you can see, okay, just think of it like this. master station always wants to go out of the A side and see everything from A coming all the way to B, right? Okay, so if the master station can only see actuator number 1, let's call this actuator number 1, address 1, okay? But it's in loopback. And it's picking up everybody else on the B side. So at one address, it's going to throw up as 1. The other one, it's going to say, but I can see 2 and 3 on the B side, right? But it can't see. So what that's telling you is either one of two things is going on. Either the B channel of this card is a problem, okay? Or it could be the A channel on this card is bad. It's going to be one or the other. It's going to be, so it's almost like it's a crapshoot to figure out which one it is, okay? But if I can communicate this way and I can only see to here, well, that's telling me my B channel is good on this guy coming from the backside, but it's not telling me about my A side. I can't see A from here. I can't see it from either side. So it's either here or here. Or guess what? Maybe I got a bad piece of cable right here. Maybe this cable's all burned up. At a refinery just recently, we did a project, and they fired up the coker system, and we lost a part of the network. Not a part of the network. We lost some MOVs. Okay. Well, it turns out when they put the system back online, they didn't re-insulate the conduit, because the conduit was originally had this heavy insulation on it. They didn't re-insulate this one part of the conduit, and they literally melted the conductors, I mean the jacketing on the cable to the inside of the conduit. Yeah, there's a dead short inside the conduit. So, yeah, we were having this weird problem here. It's like, what is going on? You hook up your pack tester. Wait a minute, I can communicate here. I can see this B, the B side is good. The A side here is good. What gives? Oh, but wait a minute. You test the cable. I got continuity between the cable and the conduit casing. Like, how is that possible? How is that possible? So you pull the cable out, and literally it was toast. So it's either that, or okay, you could have a bad A or a B channel. I'd look at the simple stuff first before you get all heroic. You know what I mean? I look for the simple things first. Maybe what you could do is, just as a test, you could disconnect the wire going out on the B side, and maybe you can connect what's landed on A, just bring it right over to B, and then fire everything up. If you still don't see that actuator, you just proved out that you have a bad B channel. That's another way to troubleshoot. Okay? So there's a lot of different ways to attack it, but the beauty is the system's going to tell you where to be doing all this wonderful testing, and that you're not just kind of running around aimlessly looking for where you need to go troubleshoot. You're in an area. Okay? So that's just kind of showing you on the internal level how this stuff is wired and how simple it can be when you're just looking at, 2 or 3 wires that you have to deal with to troubleshoot. Okay? Using the master station as a guide. Okay? This is just another demonstration of what's happening when you have a loop fault. Okay? When I tell you these relays actually close to isolate an actuator when you go into fault. Okay? And it literally reports where the fault is. Okay? This is just more on a schematic level, showing you what it looks like. Okay? This is your typical termination points in an actuator right here. So you can see the terminals now. When you look at our wiring schematics for the actuator itself, this is what you're always going to see at the bottom of the schematic right here. Okay? 26, 27, 28. So it's always, this is how it's labeled. In and out. 26 and 27. Those are the most important wires right there. 26 and 27 when you think about a pacscan actuator. And your common, it's okay, because they're, if you're using red and black, maybe you're landing both your commons your blacks are commons, and they're always gonna be together under 28, okay? You only gotta worry about your reds, just don't mix them up, okay? There's also the screen, okay? And how we're able to be a little bit more effective about filtering out noise on these networks is simply that we're running this through like a little tank circuit here, okay? There's a little capacitor, resistor capacitor network here in itself where that allows the filter out the noise and take it straight to ground, okay? And that's on the back of the terminal block. It's on the back of the terminal block. You guys don't see it. It's just on the back side of the terminal block.
Is the shield grounded at each valve and the master station?
The shield should only be physically grounded in one place. In other words, in the actuator itself, it's not physically truly grounded. It's more like floating, okay? It's probably floating. You're gonna wanna ground it at the master station. Yes, yes. You want to create a situation for yourself, having multiple ground paths to ground loops. Yeah, those are the type of things that'll drive you nuts trying to troubleshoot those. Okay. Yeah, these guys.
On the wiring, we're going to run through and replace some of the cabling.
Okay.
So if we lift the wire off valve 3 and 4,
Okay.
all right, we're going to loop back, and the only valves we'll lose during this wire replacement will be 3 and 4.
If you pull off both sides, like for instance, if you pulled out the cable that was connecting 3 to 4, okay?
So we just disconnect.
Yeah, if you just pulled that wire out and you still had one path, you know, the incoming maybe, you probably wouldn't. I mean, it's that the interconnect cable, the one that's coming out of B on 3 and going into A on 4. If you pull that piece of cable out, you should still be good. You'll have a loop back. Yeah, exactly. And then you can replace that piece, and then you'll be in loop back.
Because that's what we're going to be doing.
Okay.
We thought we could get away with doing that without shutting it down.
It's all in how you do it. You know what I mean? You just keep in mind, it's all in how you do it. I mean, because there's ways you can do it where you're not having an effect. You'll have an alarm, okay?
Yeah.
But it won't have a detrimental
You
effect.
won't lose
And
control.
yeah, exactly. You still have control of the valve. Just make sure that you have a path back to the master station. So just kind of plan the sequence of how you're going to pull it out. Yeah, so if you do the interconnect cables, replace that piece, re-land it, and then leapfrog over and do the same thing, then that kind of keeps you whole. Okay, these are the only ones that have the web browser interface. Any old PC or laptop can do it. This is some of the screens that weren't shown that basically tell you. First screen that when you first log into this thing, it's going to tell you the overall health of the master station. Overall health. Who's in control? Are there any alarms? What's going on with my loop? Etc. Do I have any MOVs that have alarms on them? This is the first screen you'll see, and it's going to tell you just an overall snapshot of everything happening. Okay. Then there's the control screen. Okay. That allows you to see every status of your MOV. It also allows you to do control right here. View all the parameters, show the alarm, show me the torque profile. So you can go to each MOV and see specifically what the problem is with that MOV. Okay? And whatever the alarm is on that specific MOV, you can play with it here. Okay? You're not getting feedback to your control system. Okay, well, what are they getting? Does it jive with this? You're not getting it? Okay, well, we need to figure out why that is. Okay? Everything. And then there's an event logger. Okay? So something happened last night. System went down because an MOV failed to go open or failed to go closed. System goes offline. Well, I'll pull up that event log the following morning, or maybe somebody got called in let's look at the event log first. Let's see what happened. Let's see what the actuator thought was happening. All right, the control system already made up his mind. It's like, it didn't do what I wanted it to do. It didn't go open, didn't go close, but let's figure out what the actuator was thinking. Did it get to close, or whatever it was? Or it just was, it was a valve jam, or it was stalled. It was stuck in the seat, couldn't move. Okay, well, go to the event log. I'll tell you what the last set of events that took place. Good thing to look at first, okay? Or the actuator will probably have an alarm on the screen when you walk up to it, and you'll know what it is. But you could also see it from here, okay? And you could also see it from the keypad. Okay. These are just configuration parameters that can be seen. Configuration of the master station itself from the web browser. Okay, you can have this thing doing exactly what you want it to do. You can enable and disable things. You can enable and disable commands coming from the keypad. I can disable people being able to move the MOV from the web browser interface. I can set different levels of login to the master station. So like, let's say the technicians can have one level of login that allows them to look at all the diagnostics but not move a valve, you know what I mean? Or they can't change configuration stuff. So you can make it so it's safe for everybody to look at the system and get what they can out of it, but you can set different levels of login, okay? Loop diagnostics. Like I said, that's one of the main screens you want to be looking at when you're troubleshooting your loop. Like I said, you can see it from the web browser, from the keypad also. Okay, but if you're in a position with your laptop to hook up to this thing and do diagnostics, this is the screen you want to look at when it comes to loop stuff. Okay. Aux masking. Well, because the actuator is being controlled by a pacscan, a network. Well, your standard open, like hardwired open, close terminals, control terminals that you would use to send, let's say, 24 volts or 120 volts to move the valve open or move it closed, okay? You don't need those, right? Because more than likely, you're controlling it via pacscan. You're giving it a command via pacscan. So you have the ability to re-identify what those terminals are being used for now. Okay? Let's just say I had a pressure switch or a flow switch or a high level switch, okay? And I wanted to monitor the status of a switch, okay? I can wire that into what was the open terminal of the actuator. I'm now calling it digital input or aux input number 1. I can wire it into that and monitor the status of aux input number 1, and I can see that switch, level switch, flipping or going off, okay? Changing state. So, in other words, now that you're on a 2-wire network, hey, we got all these spare terminals that we can do some things with. Okay, and it allows you to re-identify what the open, close, the stop, or the ESD terminals are being used for hardwire controls, because in essence you're really not using them unless maybe you have a control panel that you want to still be able to control the actuator. That's where aux masking comes into play. Okay, so that's just another whole thing itself. So what you're doing is you're setting a code in the actuator to tell the actuator open is no longer open, it's now DI1. Close is no longer closed, it's DI2. So I'm going to send the actuator a code to tell it that it's re-identifying those discrete or hardwired control landing points. Okay. That is it for phase 2. Time, it's 11 o'clock. Well, I think we can get through this last one. And then we can break for lunch. When we come back from lunch, we can do some hands-on. Sound like a plan? Okay. This one will be pretty quick, actually. Talking about redundant systems, some of this information is redundant in a lot of ways too, but it's like explaining the same information from a different angle, okay? Okay, so what this particular PowerPoint is going to go into is the web browser facilities, advanced diagnostics, host communications, and for host communications and loop issues, and what we call blocks and parameters of the 2E or 2S master station. Now, you guys have a 2E master station, so some of that may be relevant to what you guys have at different locations, okay? Okay, so this is going through all the different things in the web browser interface, right? Okay, so what we have here, starting at the general tab, this is where I can go, and hopefully you guys would have this. You guys would have a copy of the actual configuration file that resides within your master station. If you don't have one, we have it, okay? We saved it. I don't know that if that information was turned over to you guys, but it's something that you guys should save and have, okay? If you guys had a module go out for some weird reason, you may have to reload it. If you have the software, you just simply plug into it and upload the file to it, and it's already ready to go. You install it in the backplane. Okay. So this general tab, we call it, allows you to load configuration files or save them out somewhere. Okay. There's also what they call an FCU tagging file. That's a file that basically you can edit offline. Let's just say if you have 60 MOVs at your facility, and they had a decent, maybe a 5 to 10 character tag name for that MOV, probably going through each address and typing it in and then going to the next and typing it in, that may not be the quickest way to do things. Maybe you take it offline, edit it in an XML editor or like on a spreadsheet somewhere, because you already have a list of all your MOVs. And as long as the file's in the right format, you upload it to the master station and boom, all your tags are in already. So that's a cool feature. Language files, irrelevant unless we're in China or Brazil or something. We can upload different languages to the thing. And if we released like a new version of firmware that added several new cool features, you can update your master station with all those cool features. And you would do that from this screen. Okay. Upgrade key. If you had a 60 channel master station and you guys wanted it to be a 120 channel master station, you contact Rotor and we'll give you the key that you key in to increase the memory of the master station so that you can do more with it. Okay. This is network settings. Okay. This would be what David Charles would be using to set up his communication via Ethernet to the master station. This is also the address and stuff that we would be using if I wanted to log in with the web browser interface. So I'd be literally putting this IP address up in my web browser, and these screens come up. Okay. Go to your web browser, just put in an IP address, and boom, there you are. Okay. Different login levels, administrator, sales, or whatever, super user, however you want to do it. Okay. You could set this system up to send somebody an email if certain alarms took place on, let's say, certain MOVs or in the system in general. If you had a critical MOV where somebody needs to be out here, if something happened, you can set this system up to email somebody, shoot them an email, to let them know something took place. But you can also, like I said, configure it as to what, what it is you want to send. And also, basically you can tell it, you can select which MOVs you want to report, or it can be all of them, and what type of alarm you want going back. Specifics. Okay. The 2E master station does, like I said, have the capability, the 2E and the 2S have the capability of doing Ethernet also. Okay? But you would have to buy this additional little box, which is just your network interface that would plug into the 2E master station. Okay. All right. So basically, this is like these are like the next couple of slides are examples of the types of problems that you would typically run into. Okay. All right. So actuator doesn't respond as I expect. Okay. So, all right. That's typically all of the problem you run into. The actuator's not responding. It's stopped. It's not doing something. You're asking it to open, to close, or do something. It's not happening. Okay. So it can be one of two things. Something going on with the host, PLC. If that's not a problem, then there's something going on with the loop. Okay. Or maybe there's something going on with the actuator itself. Okay. So if you're not getting any host communications, well, that's an easier one to troubleshoot because there's certain parameters that need to be lined up between the master station and the host, just like anything else. Okay. If two devices are going to communicate with each other, they have to be one talking the same language. They got to be talking at the same speed, okay, and all of those different things. So, if the host port is set at 9600 on the master station, but the DCS or your PLC is set up to communicate at 19.2, they're not going to talk. Communication will not even start. Okay, so these are the types of things. Or it could be that if you were doing the Ethernet setup, maybe there's something wrong with this addressing right here. Maybe they forgot there's a gateway address that they still need to put in here also. Okay, so these are the types of things that harm host communication rather than the cable just not being physically connected to the master station. It could just be a setting in the master station or on the control system side. They're not matched up. When I look at my screen here, I should be able to walk over to David Charles and say, all right, is this how you're set up on your side? And we need to be, we need to be in lockstep there, okay? And so long as we are, communication should flow, okay? So valve does not behave, typical scenario here, hey, that valve is supposed to close. Typical scenario where the valve does not behave and respond to a command in the manner the integrator expects, or he doesn't get the feedback he expects. That's always more than likely going to have something to do with the communication between the host and the master station. There's no way that you guys would click on the screen and give the valve an open command and it goes closed. Because you're writing to a very specific location to close or open the valve. There's no bones about it. The database is set You can't alter it in the master station, so you only need to write to the right location. If you write to the wrong location, you're gonna get something wrong is gonna happen, okay? If you're trying to move MOV number 1, and you give it an open command, and MOV number 3 goes open instead, then we know we have a mapping issue between the DCS or the PLC and the master station. There's just no other way it can
Is
happen.
it possibly the wrong address? If you,
You could, yes, if you address the MOV incorrectly, then yes, that could happen. Could happen. So, well, we have this thing called a protocol analyzer on the master station where we can determine the source of commands and where they came from. And if you knew how to read Modbus information, then you would be able to kind of break down these messages and determine where it came from. But this is showing me the master station data logger logs where commands are coming from. So right here, it's seeing that the source of the commands are my web pages. Okay, right here it's saying RTU number 1. That's where the host is connected. That's where those commands came from. Right here, it's saying that I'm getting commands from the keypad. All right, and right here again, it's saying I got it from the web pages. So if they told me that we didn't issue a command to that MOV, I'd be like, well, all right, well, somebody did from the web page or from, you'd be able, and everything is time and date stamped. So you're able to see the source of the command and when it was sent and everything like that, okay? So you'll be able to track it. So if somebody said a valve moved on its own miraculously, I'd be looking at this first to see where the heck that command came from and what time did this take place. And you can also pull the actuator's data logger also and get that same information also, okay? The host analyzer also, this is more advanced diagnostics. I don't know how deep you guys would ever get into this, but diagnosing Modbus messaging flowing back and forth, this is on the data link level. When I say that the master station is communicating with your PLC, what does communication even look like? Okay? There is a way that you can look. See, there's a transmit and a receive, a transmit and a receive, a transmit and a receive. Okay? So the receive messages are the ones coming from the PLC. Okay? The transmit message is the response to the question coming from the PLC. Okay? And you can see that the master station and the PLC are communicating. For every transmit, for every received message, there's a transmit back. And you can always look at the front part of the message is always an echo of the actual question. Okay? So if I looked at that, I'd say, yeah, we're communicating. But there is a way to actually look at this information. And this is why I'm going to give you guys this information so that you can kind of look at it kind of offline a little bit because, so I've worked on this stuff kind of for years, so I kind of know how to read Modbus messaging. And somebody say, hey, how you read the matrix? It's like the matrix, just, it's very, and I'm going to show you an example right over here, okay? That's how you break down these messages, right? So, here's a received message, and there's the transmitted message from the master station, let's just say, right? So, the very first character is always going to be the address. Who am I talking to? What's your address? Okay, address number 5? Okay. The next thing is Modbus function code. Well, if you knew what Modbus function codes were, Modbus function codes are different things that you want to happen via Modbus. Are you reading or are you writing? Am I reading multiple bits of information or am I writing multiple bits of information? And that's it. Okay, so, hey, address 5, I'm going to use function code 3. And I want information starting at register 0 and give me 2 registers worth of information. So the response should be always, hey, yes, I agree that I am number 5. I agree that you are doing function code 3, and here is the data you requested. Okay? If you were to flip those numbers into binary or into decimal, then you'd be able to know exactly what's happening. Like I said, binary, because remember, you're reading 16 bits of data from each actuator. I can tell you which bit is turned on. I can tell you that the valve is open. I can tell you that the valve is in remote. I can tell you that it has a thermal overload. And I can tell you everything based on those numbers. Okay? Like I said, this is troubleshooting down to the data length level. All I'm saying is that this master station gives you the ability to find root cause of problems. Okay, I guess that's the main point I want to get across, is that at any level, as far as troubleshooting is concerned, there is information that David Charles will be able to use to get to the very pinpoint specifically what this problem is. There's information that you guys can use to pinpoint specifically what a problem is. And all of that is built into the master station. It's all there. It's all there. You know what I mean? So it all depends on how deep you want to go, but all the information is there for you. Okay. We've already seen this screen. Okay. Fault types and diagnostic. We're going to actually see this in real life. Okay. This talks to you about cabling a little bit, about the type of cable that you select, and knowing what the capacitance of that cable is. So like, you guys, have you bought the new cable already? Did we give you guys a cut sheet or recommendation on the cable? Okay, good.
We replaced it with
Okay, good, perfect. Then you guys are good to go. I had a customer that bought an off-brand cable. It was the same twisted shielded pair, at least they thought, but for some reason the capacitance of that cable was like 4 times the capacitance of the cable we recommended. So guess what? When you have a cable with super, super high capacitance, you cannot run at a high baud rate. You gotta run slow, okay? There's a maximum amount of capacitance. So this chart right here tells you the number of field units and what speed you can communicate at for, the capacity, per the capacitance of cable that you're running. So always an important thing to know. And if you're replacing like for like, you're probably better off. But there is a way, the potential exists that you could have like 3 different types of cables, they're all different types of capacitance running. Now, is that a big problem? It's not a big problem. The only thing it's going to do is, like, if the capacitance is too high, you're just going to have to run at a slower speed. Or, is that the bottom line is once a whole network is wired up, we take capacitance readings of the whole network anyway, okay? And we take resistance readings of the whole network anyway. And we tune our voltage based on those readings. So if it's high, well, guess what? Then we just tune to suit what's there, okay? So is it a big problem? The only time you run into a problem is if you want to go to a faster speed and the capacitance doesn't allow you to go that route. Other than that, not too much of a big deal.
I'm assuming since we're replacing our cable, I think you guys recommended that we do that because we may have a bad section in some place.
Yeah.
Our
Yep. Yes.
tuning will change, so we should take those readings after we install it.
After you install it, then let's look at it again, because we may be able to dial back the loop current a little bit, okay? So these are, when you have like mysterious, weirdo type of stuff happening on your network, you got to get back to fundamentals, okay? And this is kind of what we started with you guys. Just weird anomalies just happen, and then you reset something and it goes away. I don't like those types of, I like a problem when it happens, it locks itself in. At least it commits and says, okay, I'm here, you know? And he's like,
Those will embarrass you.
exactly. But when you have all this kind of weird, you know, we're on an ancient burial ground situation type of thing happening, you want to go back to basics, and you want to start taking some readings to see exactly where you're at. All right, so you see here, these are the types of readings. If I was going to go through and say, we're going to start from scratch, power everything down. You guys are in shutdown right now. Let's start going through it. I'm going to take every one of these readings right here. Okay, we're going to go through it. Okay, and then we're going to go back and we're going to double check, make sure we don't have any shorts anywhere and everything like that. And then we're going to tune the loop to where it should be. Okay, so we have a little chart that we use as to all the different types of stuff we want to get. And once you get through it, then at least you know where you stand, and then you know what direction you need to go. Now I know that when you guys had your outage, you know Gordon did a lot of this diagnostic on your loop. So we have snapshots from the scope of what it looks like. You know, when you guys are in startup, everything we got everything. So should be able to get to the bottom of anything that's happening at this point. Okay. Looking at it from the scope, it kind of, there's a way that these waveforms need to look, or these square waves need to look, okay? You always see communication from the master station and then response from the field units, okay? And that's what it almost would look like right there, okay? If I see anything that looks outside of that, where I see other little peaks and valleys superimposed on the top of any of these, then I know I've got issues. Okay, looking at it from the scope level. Okay. In other words, it needs to look clean. It's clean square wave here. I don't know why they're showing me like almost like a slope here. That's not what it would look like. If you see that, then you could potentially have something going on. Okay, but it's more like a square, 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 square. Okay. Here, kind of like this, okay? This is what it would look like, all right? This has a little bit of noise, but not enough noise to throw my network out of whack, because all of the messaging is pretty clean still. I still have clean square waves, I just have noise superimposed over the top of it, okay? In this example right here. This, on the other hand, the messaging is not discernible whatsoever. That's a problem. That's water in the conduit, raising the capacitance way out of town, okay? But that's just a direct short and noise being induced onto the loop, totally distorting what I'm looking for as far as a waveform. Like I said, we can handle some noise, we can filter it out, but you can see that the signal is still intact for the most part. That's the problem, okay? This is the kind of stuff we don't see. And we see this happening when maybe a certain piece of equipment starts up. You know what I mean? It gets bad and then it goes normal again. And it gets bad and goes normal again, okay? We need to figure out what the source of that problem is and deal with it somehow. That's all. Okay. Bottom parameter. Okay, so these are, okay, this is for the 2E and the 2S master station. So yeah, what these are basically telling you what parameters there are in the actuators that you're setting up on a, what can you see from the 2E in essence? Remember I said like on the P3, there's that one screen where you can change like your deadband and stuff like that, okay? Or if it was a torque, if you guys were pulling back the analog value for torque, how often is that torque being fed back, all right? this is the same, in essence, that you would see in the 2E master station. These are the things that you can set. In all cases, though, you're setting it, most of these at the actuator, or with the pack tester, okay, which I don't even know if you guys have. Do you guys have a pack tester?
Double check with our.
Yeah, yeah. I wonder if you guys do, because if not, you guys should. I think you guys ordered one though. I think, as a matter of fact, you guys. I think you guys did. I think you guys, we ordered one for you guys. Or the IQ communicator. IQ communicator. For those Mark I actuators that you have out there, the older multi-turn dark gray actuators with the battery and the side cover. You're either setting those up with a setting tool or what they call an IQ communicator, which was an old school PDA. Called Scion communicator. Okay, and it had a big old infrared plug on it. Those are the only ways to actually communicate with those. But you can use the setting tool also. Okay. You can set more things up with the communicator on those than you can even with the setting tool. Some of these parameters aren't even available by the setting tool. But you guys have like a grand total of, I think, 3 of these actuators left at this point. So I don't know how often you would even be getting into those. And that is the end of that stuff. All right, so it's just about lunch.
All right, you're on.
Okay,
And what you use for the battery?
all right, so now, guys, what we're gonna do now is we're gonna get into the practical version of our training, which is actually the hands-on version of it. So what we have here on the table is 2 IQT actuators, okay? Now, I kind of got them pre-wired a little bit, but I think we should take these wires off, okay? Because what I want you guys to do is somehow figure out how, and I'll put some stuff up on the board to guide you on it, but you guys need to create a loop and wire this loop into our master station. So that's the first step, okay? Once you guys are confident in that you've done the connections properly from the master station through your MOVs and back, then we're going to fire up the master station and we're going to verify that everything is correct, okay? Then also I want you to give these guys a couple of addresses, okay? I know one of them is address 1 and one of them is address 2. You guys can go through, change them to whatever addresses you want them to be, probably something lower than 60, or maybe, yeah, something like that, okay? And give them a unique address, and then let's see how we make out. Now, if you guys wired up right the first time, and then we fired up, there ain't nothing to diagnose. Now, all we're gonna do after that is then we're going to induce different types of faults to see what they look like, okay? And using the diagnostic screen to go through and troubleshoot. Okay, so there you have it. Matt, can you grab me one of those screwdrivers so I can disconnect these wires from the terminals? And then I'm going to put up a diagram, and then you guys should just be able to wire this up from
28 and 26.
That's right, 28, 26. So remember your
26.
your numbers, the numbers that you need to be concerned with are 26, 27, and 28. 26 is incoming, 28 is common, 27 is outgoing. So from the master station, out into 26 and 28, out of that, 27 and 28 into 26 and 28 on the next, and out of 27 and 28 back to the master station. Should be that simple, but it's not usually. So, because polarity can play into this bad boy a bit, I'll tell you.
Take a picture now.
Yeah, there's no, you gotta do with whatever you gotta do. I mean, it's, you
Yeah.
take pictures and,
Yeah, exactly, exactly. So, all we gotta do is, well, let's go ahead and, well, we leave these powered down for the
Yeah,
time
no,
being.
no plug,
Okay?
no plug now.
No, we know that this is how, it's set up to give you a shock if you get it wrong. Okay, no. Yeah. All right, guys. So, all right. Somehow, this is your plug on the master station side of it. You need to get back into this plug, okay? I'm going to put up a diagram that shows you how this plug is pinned out so you know what the A in and out and B in and out is on this plug right here, okay? So I'll throw that up.
From one end and go to the next.
Yep.
Limit ID.
So you're going into here, and we'll take it from there. Let me put something up here for you. Go ahead, Efra.
Take a picture, Jake. Come on.
Now's the time to do it. You got a system running and you're trying to work on it. That's the problem.
That's why I take a picture now. Now, well, you can. Well, you're not too close.
No.
Take a picture, take a picture. I don't need to take, my
Which
picture's up
phone is
here.
that? That's an
Yeah, you
iPhone.
can
Oh, yeah,
search that plug on the master station, okay?
Correct.
This is the plug that's in the loop driver module, okay? So if you hold that plug up against this picture here, this is the quick start guide, okay? This
Okay,
will be on your,
that's 1 through 6.
exactly. So when you look here, and you see leaving the master station, going out across your loop and then back or this way, okay? 4, 5, 6, 1, 2, 3. That's referring to the terminals on that plug. So this is just showing you.
Then going out is 4, 5, and 6.
4, 5, and 6 is going
Going
out.
out. It's coming back 1, 2, 3.
You got it. Yeah, so I mean, easier to remember, it's not intuitive. The front is not A. The, go figure. But front is always gonna be your B side, okay? So, yep. Boom. 4 and 5 is the one you guys need to be looking for. So now,
Correct.
4 and 5.
yeah.
Hey, Jay, you should take a picture of that.
Okay.
Look, that's the block. Connector. No, but go ahead.
It's talking on A, and then it's also talking on B. What is that telling you? Because we always want it to be talking out of one side.
Listening on the other one, right?
Yep. And if it's,
So the top one's talk and the bottom one's listen?
no, what it is this guy should just be the only one on. Or you want to see him on solid, okay, where, you see
One's flashing
communication.
and one's solid, you're saying?
Yeah, so but what you see here is it's flashing a little bit here and a little bit there.
That's not right.
What it's doing, it's communicating as far as it can on the A side, and it's picking up stuff on the B side. See what I mean? Because these lights are flashing out of sequence, so it's getting a little bit here and a little bit there.
Okay.
So that means I can just look at the lights and I know that we're in loop back. Because once we correct this situation, watch what it looks like. Okay. So now, going through the menus to find your problem. Okay. We already see 3 X's, so we
Yeah.
know that there's a combination of issues out there. We got alarms on the actuators because field network status. Okay, the network status, we have an alarm. So that means something's up with our wiring, okay? Field network status, network comms, I'm not seeing something. Somebody's not being seen, okay? Field unit status.
Oh.
There is an alarm.
Another thing is you gotta put in remote.
That's right.
Yeah, and that's another thing.
Yeah.
Okay?
See, that,
All right.
you should see, that's where, this is an example, if you guys want to make sure, look, when it's in stop or local, you'll see an alarm on there, but that's where you always should go to the front of you should always go to the unit and look.
You gotta go see what you got first. Okay, so the first thing I wanna go to is, I wanna go to my diagnostic screen, okay?
Which one's remote? Oh, that's remote.
This is remote? Stop.
Okay. So we're gonna look at this in two different ways. One way, I'm gonna get my laptop plugged in here in a second so we can see that, okay? But if we just come up to the master station, you wanna deal with this, okay? This is your main screen. This is me keying over left and right to select what I wanna do. Here's diagnostics. The magnifying glass is diagnostics.
Okay.
The actuator is control actuator stuff, okay? And settings is the wrench,
Okay.
okay? In my case, I wanna go do some diagnostics, okay? So, gives you a slot 1. Notice there's a big X through it because there is no slot 1. This is slot 1. It's a blank play, so it's correct. But there is a slot 2. Here's how you know what slots. Option 1, option 2. That's your slot number. There's slot 2. Okay, so I'm gonna move over here. Slot 2, hit enter. It's telling me that my loop backs are on. So I got a loop back on.
Okay.
It's in loop back mode. It's looping back on itself at FCUs 0 and 60. So one of these guys must be address
0 and 60, right?
Well,
What's weird is I have address 1, where right one, so I'm not sure where 0 and 60.
no.
This guy's 1,
And what's this guy?
I didn't check yet.
Take a look.
This is the one that's inside the building, huh? Because we have issues. I'm too bad they didn't have the other one, so we could see, since the outside one's the one who gives us the most problems, the valves, going through that controller instead of this one. Because they're two different looking.
Yeah, they are different.
And they didn't have one with them. Because it totally looks different.
Yeah, 60.
60? Okay. But guess what address 0 is? It's the master station. So think of it as ground zero. Ground zero. This is where it all starts, right? If I have a loop fault between 0 and 60, it's between here and there.
That one.
So somebody needs to figure out what's going on. And then, here's what it's telling me also. FCUs on the A side, none. So coming out of my A line, or out of terminals 4 and 5, I'm not seeing anything. I don't see that actuator. Okay? All right? On the B side, I found 1.
Oh, this one.
So how is it from the B side, coming from the back, I'm tagging this actuator, the first one on the loop, and this guy's not even here. Somehow I'm seeing through this guy into there. How's that happening? So you gotta sort your wires, figure it out. So that's our first problem, okay? Now, if you wanna double check everything, okay, what I do is I start and I do a loop reset. And that'll bring you the latest and greatest information, because this will also tell you if you have a roving issue also. You're gonna reset it, it should come right back to the same exact fault that you had. So always just do that first. It's not gonna hurt anything, it's not gonna take the system offline, it's just, the system's gonna hiccup for a minute while it just simply resets and goes back and finds all the MOVs one more time, so. From this page right here where you're looking at the diagnostics, you just arrow down once and hit reset and hit enter.
Okay.
It's always gonna ask you,
Are you sure?
are you sure? Yes. Then you can kind of watch and see what it's doing while it's going through the reboot sequence. You also look at the lights and see what the lights are doing. Port A. So right now, when you see the port light turn on, it's firing down port A to see how far it can get. Then you see the port B light turn on, it fires down port B to see how far it can get. And then it settles out. And you shouldn't have the lights going back and forth, because now it's compensating, trying to talk out of both sides. And there's a reason why. So double check your wiring and make sure that everything's correct, starting from the A side going to address 60, right? Address 60 is there.
Is this one?
Yeah, so from here,
This one is for this one. Oh, it came out?
okay. So start from this wire and trace it all the way back out. Out, in, out in.
So the one,
Wait, back. So I'm all backwards. Okay. Okay, let's see here. So we're gonna go to diagnostics, position 2. Oh, okay. It looks a little bit different, but let's go ahead and reset the loop again. I think we're seeing 2 MOVs now. But I think we still have an issue.
Well, we only see one right here.
It's going out and trying to find everybody. Okay, so I'm
Okay,
going
now
back.
it's on the second light. Right.
see the numbers.
So it's firing out the A, and then it's firing out the B, and then when it comes back, you got your result.
The back one's 27.
Still got to loop back. And like I said, just because I'm looking at the lights, I'm telling you that. But there you go. Loop back's on. FCU, so it's between 1 and 60. So you're seeing 1 on each side. Now imagine if you guys had a loop of 20 or more actuators. You see how it can get kind of yeah. Well, you can split it down. Well, that's it. Right? Split it right down the middle. That's an excellent way to think about it. If you split the loop right down the middle and see what you can see on the A side, it's like I can see up to address 15, and you just start patching them in one at a time, and just follow a path all the way down. Then you're done. So
Loop back on
Instead
X2.
2, like
I
times
think the doubling feature, I turned it on just to show the guys how to do it at another trading class. But yeah,
So what does that mean? It says loop back on X2?
No,
Yeah.
times 2.
No, that means
times 2.
Yeah, but what you have,
Loop back on, basically,
yeah, loop backs are on, and then
through loop backs through 1 and 60.
And 60.
yeah,
So between these two. So the way these are connected, which is telling me,
yeah,
between these two, you
how
gotta
they're
change the connection
connected this
from
way.
here to here.
Right, and because another way to verify that is it's telling you how many it sees coming out of A, and then versus how many it sees coming out of B.
Okay, 1 and 1.
At
Yeah.
1 and 1, so that's telling me you're good this way. So
But
it's
no in between them.
something in the middle
Between
might
these
be.
two.
Yeah, it's
Yeah.
this one and this one and see.
So how are they connected? We gotta see how they're connected, right?
Yeah,
So,
we have to verify this now.
so we gotta see where they're
Is
connected. Where's
this
this
cable?
going?
Is this cable?
Which one?
Yeah, it is one.
Yeah.
Yep, that one right here.
That's the one.
Okay, where's that going right there? Going right there?
Okay, here
It's
it
this
goes
right
to
here.
26 and
And then right
28.
here. This one right here.
You better go from one point and just work your all the way around.
It's best to do that, unless you had somebody go through and label every
So,
cable.
this is it right here.
And
And you're sure
and
that.
you're sure that everything is.
So what's the easiest?
It's just easier.
Both of
to
them,
do it that way.
where's yours at going over there? Is this one right here?
Yeah, it's this one.
So either one, we have to swap it.
Yeah, good.
Okay, you
That's why
wanna do it
make
here?
sure. See, I always
It's gonna be
know
this right
that.
here, right?
See how they got.
Yeah, but how you
Black,
do
white,
that?
black.
Because now you
It's always
have
gonna be white,
this
black,
one
white.
going back.
You know what I
Gonna be
mean?
always
But
white.
that's no problem for
White,
that one
black,
though.
black,
No.
white, or black,
Right.
white, white. You know what I mean? It's always gonna, it's not gonna
Be
follow.
opposite.
Yeah.
So how many scenarios can we do it though? Because
Yeah,
it's only
because you
two
kinda,
wires,
you can
right?
take some
Exactly,
back.
there's no way that.
We have to have a common, right?
Exactly.
Before you
yeah.
start.
So let's swap it. Right? Because it says between these two,
Mm-hmm.
right? Just watch out for your hot wires down there.
Are we can drop, either drop the power if you want or not. So it'll be on the actuator.
Good with that,
Everything's
with the power?
covered.
I don't feel nothing yet, but
As long as you have, as long as you have the shield, yeah. As long as you have the covers on, you're safe.
Someone did that to me one time. I was troubleshooting
Wow.
control failure, and I'm over there with my meter like this, and somebody came up behind me and went,
I hate that. Grab your leg or come in there like, bah!
You don't need enemies.
No.
Here, guys.
Uh-huh.
As you're going down, status.
Uh-huh.
So status is the actual discrete feedback from the thing. You know, the alarms, not alarms, but it's just regular status. Open, close, and stuff like that, okay? Just letting you know, these are things that are non-critical usually, not stopping you from running the valve, okay? Go over one, that's control, so that's where you guys can control it, and I think Matt showed you that.
Yeah, we're just gonna
Okay.
work through it.
That's settings. More than likely you guys won't ever mess with that, but if you ever had to, I'd be doing these settings at the actuator and not from here. That's just my preference, okay? Deadband and stuff like that, because you want to be at the actuator to see what it's doing anyway. I would set it from here, okay? Alarms. That's your whole alarm screen right there, so put one of those in remote, or put that guy in remote.
That's number
I
two.
mean, in local. That's number 2?
That's number 2, yeah.
Put that guy in, because I'm not on it, just, but I can, so you see right there, as soon as it came in, monitor relay came in, that's the first thing right there, and then local,
Local.
okay? If I want to go to the next one, I just simply, you see where the,
It's in locals as well.
if I want to page over, that one's clear, it's not an alarm right now, but if you were to put that guy in local, then it would pop up, okay? And there you go. Basically telling us control's not available. So these alarms right here, all of the alarms that pop up here are things that would prevent you from running this MOV. So if you come up to this thing and you see any of these alarms in, more than likely, you wouldn't even be able to run it from here. They definitely wouldn't be able to run it from the control system, and you'll have an alarm on the front of that MOV. So you need to figure out what it is. It'll be jammed, obstructed. It could be in local. You can't do it, in other words. So,
Off.
yep.
And stop.
So now it's in stop. So as long as you see that monitor relay in play, and along with any of its cronies, as far as alarms here, those are deal breakers, okay? As far as being able to do anything.
Is this layout pretty much the same as the 2E?
Somewhat, except, you know, as opposed to, I mean, you just have a nice graphic, as opposed to just kind of being able to read the, I guess, the alarm code or the little hieroglyph. Okay. Yeah, it's a little bit more intuitive looking at it, I guess. Yeah, as opposed to going into just alarms and you're able to reset and clear alarms and all that. This thing will automatically reset alarms. You don't have to reset the alarms. Well, you do need to do a reset of the alarm, but like switching from local to remote right here, I don't have to go back in here and clear the alarm to make it go away.
Whereas on the other one you would.
Yeah. You don't have to do that here. It'll just automatically update.
It doesn't look, of course, like that.
No.
It's like a keypad and everything.
Yeah. So, yeah, it's one of those things, if you get used to, that's the thing with the 2E, you get used to working that keypad, and, you know, you're usually good to go. Now, I was talking about a torque profile. Obviously, this guy hasn't seen much torque these days, only because it's not mounted to anything.
To anything, yeah.
But it's going to go out and it's going to take a look. It's going to take a look at the data log, and it's going to look at the torque profile to see what it has been. And as you can see,
Zero.
it's not been pulling any torque. That's on average, it's pulling just a little bit above zero torque.
Yeah, exactly. That's
could
right
put-
there. Just a,
I could put like 40 and have for close on torque.
Yeah, then you would see it, you know,
Yeah,
climb
with
up
spike,
that
you
way.
want to do that? I can,
Go ahead, yeah, do that, and then should spike.
it'll spike at the end.
Where do you see the number at on that, the percentage?
Well, it's down there. It's just like really low.
Might be average, but
You
I'm
can
not
barely
sure.
see it. Yeah, and for opening and closing.
But it's not average in
It's just not mounted. It's not mounted to anything.
James
exactly, it's
probably
not
would know
gonna
exactly.
have
Yeah.
any torque.
Yeah.
Hey, James, how many
Hold on
does
to it, man, see if you can
average?
twerk it out.
Does it average
Oh, yeah.
like the last 10 strokes or operations or?
I think that, well, the way the data logger works, it's actually grabbing,
Be able to go glue, no.
it grabs
Everything I wanna do.
1,024 events. So it's gonna go back over, I think, for whatever strokes are in its queue, as far as actual valve strokes are in its queue, it's gonna just take an average of all of those. So this thing saves,
Good for
Disconnect.
a year
So
and
now
all of a
that's
sudden it
good.
starts binding
And I
up,
always,
you may not
what I
see
end
it
up
on the
doing is I
profile
usually
right
try to
away.
suck it back.
yeah,
to make sure
so it's
cooking.
almost like
But
if you, especially on a valve that you're moving often, good to get one profile, like in the early days, okay? And then,
Later, later.
and then
you know,
view it
went
in
farther
6
and it
months.
torqued, but,
View it in
I
6
don't have
months and
mine,
see where you're at, okay?
you
But
could
keep in
see
mind,
what
if
the
it's a
running
modulating
torque
valve,
would be.
every
But
time,
let's
every
try it
single
again.
thing that happens to the actuator is an event. So you've got 1,024 events before it starts.
Versus a year for the other,
It-
or
it-
an hour versus.
Exactly.
Yeah,
So
if you're-
what it's gonna do is it
So-
starts, and once it gets to that 1,024th event, it's gonna
hear it
roll
kinda
back
kicking.
around and start
40 is not
erasing
that
from the
far.
front end and,
First in, last out.
Okay,
exactly.
James, you should see at the close a little more torque.
What address is that?
That's one.
Put numbers
Okay.
to see in the graph.
So, let's see how quickly that.
I mean,
would have
40 isn't
updated.
much,
You put some numbers.
Oops, I'm on address 2. Okay. Still not giving me much.
yeah, it was like, you could hear it bind up a little bit, but.
Well, it's probably not enough to skew the average, you know what I mean?
Yeah.
Yeah, there's not enough.
But you could look at the average and then stroke it and look at the instantaneous and say, huh.
Yeah, exactly. That
I'm gonna
that
put
is
it
true.
back to, limit.
Okay. All right. So let's look at connecting up with a laptop.
Yeah, see, now it's saying torque trip close because I put it back to limit.
Uh-huh.
So obviously it said, hey, you're torqued right now.
Ah, okay.
So we're gonna open.
Normally going 40% torque, and now it's running 40%.
Once I give you your thumb drives with all this wonderful information, this quick start guide, okay? It is literally a 2-page, 3-page document, okay? That gives you a quick step-by-step on everything, okay? How you cable this thing up, how you set up your laptop to connect, and pretty much, you know, just the works, okay? And just, it also gives you the map of navigating through the screens right in front of the master station, okay? So, if this was something to probably have up in the panel where your master station is located, I'd probably laminate it and have it right up in there, probably. That'd probably be a good idea. Because it's a get once over, and it's all compact, it's perfect, okay? So this is telling me exactly how, the steps I need to go through to connect my laptop to the master station, okay? So one of the first things you have to do is you need to know what your IP address and everything is.
Your master station?
Of the master station. So how do you find that? Come on over really quick, and I'll show you guys where you find that information, okay? So, I'm taking myself back to the main menu. I'll just tilt this thing up so you guys can all see.
Yeah, it's doing crazy too.
Yeah.
It's been doing that.
Good thing that the camera's not seeing. Okay. All right.
Come on.
Yeah, disconnect
Let me,
that.
let me disconnect. Maybe it's trying to think.
When you connect that, it starts doing that.
Yeah?
Yeah.
You know what it's telling me? That tells me that I need a firmware update.
Yeah.
No, it does. I mean,
Really?
Yeah, there was an issue once upon a time where they weren't allocating memory properly. So
Yeah, this is exactly what was doing when you
Power
connected
that sucker down and.
the Cat 5.
On Mexico?
Okay. This will never happen on yours. It was when it went through the x-rays at the airport. That was actually moving. Okay. All right, so what I'm gonna show you is where you go in here to find the IP address and the network configuration settings for the actuator. Then, I mean not the actuator, but for the master station. Then, the next step is to set up your laptop so that your laptop itself is on the same network and sub-network. Okay, so figure out this part of it, then go over to your laptop and get your laptop on the same network, okay? So, once we do that.
To change the IP address on the laptop to this one. To talk
It's
to
not,
this one.
it's not going to be the same IP address. It's going to be, let's just say if the IP address was 192.10.60.1.
Uh-huh.
Your laptop should be 192.10.60.3.
Oh, I see.
Or 2.
Yeah,
Just,
you can do that.
in other words, they're on the same network, but different nodes on the same network, okay? So that's the important piece. Okay, so I want to go to settings. Okay, settings. Host settings, host,
Host.
right
Okay.
there. Ethernet settings,
Mm-hmm.
and there it is. So,
Was 10.
10.55.51.
Yeah, okay.
Okay, and then 255, 255, 255.
That's the mask.
You need you always look at the IP and the mask. So when I set up my laptop, I'm gonna be 10.55.53. I always go 2 away from what this is, okay?
53, okay.
And then I use the same subnet mask,
Yeah,
Okay.
that had to be.
all right? And then that's it. That's it. Now, if you have gateways and different switches and stuff like that, and you have different addresses all through here, you need to set that up here. You gotta get through each of those gateways, so. But that's the typical, simple way to do it, okay? So, 10.55.51, all right?
Area 51.
So now, I have to go to my laptop. Excuse all my icons.
Yeah, I have a bunch of them.
Okay, so I'm gonna go to Control Center, Control Panel,
Control panel.
Control
Control
Center,
panel. Yeah, it's okay.
It's been a long day,
No, it's
okay?
close. It's
Control
fine.
Center.
We're in the event center.
All right, let's see here, we wanna go to network.
Yeah, network configuration.
This setup room is here, but
System. Where's my network thing?
Yeah, that's a good question. Where is it?
There's Network and Sharing Center.
There it is. Thanks,
Mhm.
man. Yes. Okay.
Okay, yeah.
Local area connection
Yeah, no internet.
and properties. Okay. So it's the Internet Protocol version 4. So TCP/IP IPv4. All of that instruction is right there,
Oh, okay.
right over there. Okay. Okay. I'm gonna go into that and I'm gonna change the address. 10.55.53. Ooh, I
you
must have
have
done
it.
this before.
Yeah,
Oh,
yeah, it's right there.
Okay, all right. So it's already set up, okay, in essence. So it's always going to say, yeah, save it, everything. I'm not an admin. Shut down your computer. It doesn't matter if you shut it down or not. The setting has been saved on your laptop, okay? So all I do is I bring up my web browser. I go 10.5.5.51, right?
3? Ah, 51.
51. I'm 53. I'm talking to 51. Enter. Boom. Now I'm in. All right? I don't care about that. That's later. Okay. default password is admin, default user is admin.
Oh.
But you can always change that to whatever you need it to be. Yep, admin.
Just like it is here.
They don't, yeah, but they, seems like they don't. It's like the computers, everything else. we always have it.
You're gonna have to edit that out.
Yeah. All right, so there we go. Okay, so like I said, this gives you a once over of your system, okay? This thing knows that, hey, you only have, you're configured to be a hot standby master station, but you only have half of yourself powered up. And it's a very true scenario. I look at that master station, and yes, we're completely dead on the right side.
Mm-hmm, yeah.
And it agrees with me.
Oh, okay.
So, you got a visual,
Mm-hmm.
and also something telling you about the overall status of your master station. You have all these wonderful green lights. So it's telling me that everything is good. I have no bad situation on my loop, nothing. So I'm good. So now, FCU menu. There's both of my MOVs, address 1 and address 2. Okay? In your case, it'd be whatever your tag numbers are right there. That's configurable. No comms fail. If you flip one of these guys into local really quick, we'll see what happens. Boom.
Alarm,
That quick.
yeah.
Alarm came in on that guy. And if you flip it back, it should clear. Boom. That quick. Okay? Now, if I want to go get really deep, I can go into drill deeper down into that one actuator. Okay? You always want to have green. Green is always good. Red on the alarm side might not be bad. Oh, you guys are the reverse? Okay. Can always change that around, I think. All right, so it gives me the rundown on this, the profile on this actuator. Obviously, my files are not up to date because it thinks it's an IQ versus an IQT. This picture is supposed to change depending on what type of actuator you're wired into. So it's all about firmware. These guys have been updated forever, okay? But still, it kind of serves the function, okay? Telling me that all my auxiliary inputs are inactive, valve positions closed, actuator is stationary, meaning it's not moving. If it were running it will tell you which direction it's running, clockwise versus counterclockwise, okay? Loop back is off. Loop back's on this unit, okay? Remember, if I broke the loop somewhere, if I broke the loop downwind of this guy, guess what? This guy goes in a loop back, right? Or upstream of him, he's gonna go in a loop back because remember that current source coming from the B side? You don't want to have A current source and B current source coming together. Only one of them should be operational at any given time, okay? And no alarms. So, event log, I can go through, and it kind of gives me the last few events since I've had the thing powered up, okay? 324, remote selected, moving, monitor relay, open limit. It's just literally going in steps, telling me everything is like writing down everything that happens as it's happening. Okay, that's what it's doing. It just kind of just logs it like that. Okay. All right, so I can print that out. I can save it, whatever I want to do with it. Let's see here, torque profile. Obviously, these torque profiles are not going to come up because, like I said,
There's
these
no torque.
actuators aren't seeing any torque. Nothing. And this particular torque profile is just showing you the last. This is just the last stroke. This isn't doing any averaging. It's when you pull the data log off of this thing, it's doing the averaging for you. But this is just your last complete stroke. It kind of gives you an idea of what you did. Okay. And then I can control the valve from here. And it prompts you, before you do everything, it'll prompt you to okay? So I can open or close it, or I can set it to a given set point and have it go there. So what could I gather from my position versus, okay, my position versus the actual position feedback? I'm at 25%, and then my position feedback is at 31%. What does that tell you about my deadband?
5%.
5%, right? That's probably a true case. Let's take a look. As we wait. 5%. So if I were to modify my deadband down to 1% or 0.5 or something like that, then obviously then
Your feedback would be closer to
it'd be a lot closer to your actual output. So, you know, that's,
Can you get it too tight that it sits there and goes open and close until it hits that sweet spot?
well, on these IQT actuators, cool thing is you can set the speed on these. So, and you can also set what they call slow mode. Okay? So slow mode is when the actuator gets to within a percentage of your set point, it goes at half the speed and creeps into that position. So it's not going to overshoot.
Yeah, you got it.
Yeah, okay. So that's a pretty cool feature. So that'll prevent you from doing the hunt. But these things are actually, you're good down to 0.5% on the deadband. Yeah. And there's really no lash in that gearing either. So you're not gonna, there's no
What
roll.
about hysteresis?
Hysteresis, that could come into play. It could come into play. It could. Could very well. But the thing that always think about being able to adjust the deadband and the hysteresis. We can adjust both of those on this, okay? The motion inhibit time, how much time does it take before it actually acts on your movement? So what do you think my motion inhibit time is set to right now? Motion inhibit timer is set at 2, but
Is that 2 seconds?
it's not 2 seconds because, yeah, it's pretty much instantaneous. This thing will, if I could make it happen faster, it'll just go. That's like probably 0.2 of a second, maybe, or less, or milliseconds, you know, okay? So it's also knowing the scaling of these numbers. But these settings can also be set with the setting tool at the actuator, okay? That's kind of where I would typically recommend setting it, because you kind of want to be next to the process while you're doing something. Or you can sit here and watch the valve, and, okay, in theory it's happening, but, you know, when it comes to settings, I like to kind of be in next to the process, you know, just to kind of see what's happening, or at least have somebody over near it, okay? So there you have it. So you can do all your controls, everything like that from here on this MOB, okay? System diagnostics. Okay, so the master station data logger itself, the master station data logger is looking at commands and stuff like that that are coming into the master station. So it's going and it's looking and it's saying, okay, but it's going to be looking for, there we go. All right. So most everything has come from the web page and from the display today. The last time it saw a host communication was back on 226 or 224. I had it hooked up to a control system and we were doing some testing, you know, just so we can see what the Modbus data looked like when it was communicating, trying to decode some of this messaging.
Check and see what, are you giving it a 40/20?
Yes.
Okay.
Give it
That's the
40,
master station data
go down
log.
to 4, and then see what your output is.
And then you have the host analyzer.
You know, we need to calibrate, because that's what.
The host analyzer is, again,
For that too.
just like the matrix. You can read the messaging coming through.
Thinks it's at 4.5.
Okay, but and that's, like I said, that's David Charles' business, okay?
All I see is beyond.
And then the network diagnostics, okay? So looking at this screen, it tells us that we have number of devices on the network are 2, number of devices found are 2, okay? This first number is referring to how many it thinks it should have on the network, okay? Number of FCUs it found is 2, that's always a good sign, okay? But that still doesn't tell you if you're out of the woods or not, because you could see both, but also be in loopback. But should you be concerned? I still have control over all of my MOVs, but it's just telling you that the system is healing itself to allow you to have both MOVs. But maybe you should address the problem, because the next fault may make you lose more stuff, okay? So it just because you can see everything doesn't mean that you're good. You just want to make sure that loopback is off. That's what you want, and you want to see all. For all we know, you could have an MOV powered down for some reason because you have a part of your system shut down. That's totally normal. But if you know that 4 MOVs are powered off. So you should be 4 short. And that's it, all right? It shouldn't have an effect on anything else, okay? So, all right. The last network was initialized by, so it's even telling me, what was the last reason this network was reset? Because I reset it, okay? Not because it automatically reset for some alarm situation, okay? No faults, tells me my baud rate, tells me what it can see. So whenever I go over here and I start messing around with stuff, now that you guys got your wiring all squared away, finally. So if I go doing stuff, now somebody's thinking about it. See how quickly it just automatically goes.
Turn wire
We'll
failed.
lose communication.
Waiting for loopbacks.
Now the return wire is the actual comment.
Now it sees one on A and one on B.
There it is. And it's throwing up. Whenever you see this, it's always going to highlight things, okay? It's telling you exactly where your fault is. Between two units, so it's between 1 and 2. All we got is 2 actuators. Yeah.
Now, is it smarter, the laptop version than this? Or is it?
It's just, as long as you know what you're looking at,
Yeah.
it's the same information. I mean, literally, it's the same. So let's pull up this same screen on the master station right now. Okay, so look at that screen. Okay, now let's go here. Let's go to Diagnostics, just like we went on there. We went to the Diagnostics tab, right? Okay. Let's go to 2. That's position 2, or the loop driver, like we clicked on there, the loop driver down at the bottom. And so it's telling me that loopbacks are on, right? Loopback on, over there, okay. Loopbacks are at FCUs 1 and 2. There's a graphical representation of where the loop faults are. 1 and 2 are highlighted. If there were 20 MOVs, 1 and 2 would be the only ones highlighted right now, okay. All right, FCUs found A and B side. You see that same information there. And only thing different is this is giving you the address fault, and it's telling me 0. In other words, I have no duplicate addresses on this network, okay? It's also telling me that loop fault type is an open circuit, right? And now I'd have to go over here where it says loop map. If I move my arrow over and I click loop map, now I can determine that FCU loop position 1 is FCU address number 1. Would that be correct? Because look at the first column. It's telling you loop position, right? Mm-hmm. And then if I go down, FCU number 2 is loop position number 2. Okay? So all of that information is here. You can see it. This is just looking at it all on one screen. It's just easier to look at. And that's what I mean about, But, obviously if you're in a clutch, if you're in a jam, you get a laptop all set up. You can get good at just going through this same little screen, resetting things when you have to. So, but, yeah. Get these guys some laptop. Or you could, here's another option, guys. Maybe you set up a little workstation right next to the master station. Maybe you do a little touch screen or a flat panel monitor in a keyboard. With a, you know, just a simple computer. That's its only purpose, is to
It just stays
pull up-
there.
It just stays there. Hardened workstation. That's another idea. Yeah. City of San Diego at the Metro Biosolid Center over there, they have 18 master stations. 18 master stations, and they had what they called, what we were selling back in the day, it was back in the late 90s, what we called a Pac Vision system, which was a hardened PC that's right next to this big panel of master stations controlling the whole plant. There's a dedicated PC right there that just, and we built some graphics and everything, and they can just go through and that was a 2E system at the time, but we since upgraded it, but whatever it takes, you know what I mean? To me, when you're diagnosing things, I just like it to be easy. But as long as you know where to look for things, it doesn't matter. You know, you can do the same thing with that as you can do right here. This is just a bigger screen, obviously, and I don't have to maneuver around as much, okay? But if you have that document over there, then you're able to maneuver, learn how to maneuver through the menus using the keypad, okay? So there you go. So there it is. So it's telling me I have my loop fault. It's telling me where, for the most part, it's right there. All I did was pull a wire from here. Okay, so that's an open circuit, right? Okay, so,
Short circuit?
all right. So even if I put the wires back, here's one thing I'll have to say. I put the wire, I've corrected the problem. My lights told me I corrected the problem. My system still is latched. The alarm is latched into the system. It's not automatically resetting.
This would be, right?
Correct. So the only thing that can assign loopback status or clear the loops is this guy. If you've corrected the problem, say, all right, let me go out and rebuild the loop again. Because what it's going to do now, it's going to test the A side current driver, and it's going to test the B side. Because what it has to do is it has to go back and reconfigure everybody. Watch. When I'm going to go back to the FCU menu, and you're going to see one extra thing. Okay, FCU menu. Remember when we looked at the status of the actuator, the loopbacks were off on the actuators? Okay, watch this now. Loop back on. Okay? So,
That's the last status that it's on,
yeah.
until you reset it.
Yeah, this guy is the one that's that's establishing who's loop back on and loop back off. The actuator by itself didn't say, hey, I'm in loop back. No. This guy said, no, you're in loop back because I found a problem over there, so I'm isolating one of your channels so you can't keep going somewhere. And it wrapped around the other side and says, okay, I'm isolating your channel so you can't do anything. Okay? So the loop back got turned on. The only person that can turn it off is this guy. But he's happy that he can talk to everybody, so he's not automatically just going to go reset the loop. So you're going to have to reset the loop in order to make that go away. That's one thing. It'd be nice if there was it's probably a firmware thing that can be done to have it do like an auto reset on its own, but it doesn't do it.
But it would mask a
Potential problem.
potential problem out in
yeah.
the field.
Yep. So if I go back to,
By resetting it all the time, you wouldn't see it.
yeah, you never see it unless you were monitoring that alarm, loop back on
Yeah.
status. If you were monitoring it, you say, hey, what's up with this loop back keep coming on this actuator? All right, so I can, just like I reset the loop from there, I can reset it from right here. Reset network. And it's telling you everything it's doing as it's doing it. And also, you learn to start looking at the lights, and you can see what it's doing while it's supposedly doing it, okay? Boom. So, just that quick, it cleared my alarms, okay? Just went and reconfigured everything real quick. Said, okay, I'll turn off everyone's relays, I'm good now. Okay? So, what's that click? No, I guess it's fine, yeah. That was a happy click, okay. All right, so now, what does it look like? So right now, we had an open circuit. Let's short circuit. So short circuit to me is what you guys were doing all this earlier. Yeah.
It won't be the last.
So if I cross my 26 and 27,
I'm working with launch.
simple enough. So all I gotta do is cross those up, okay? Be done anywhere, okay? Sometimes we're not always blessed with being able to wire directly from actuator to actuator. Sometimes these networks travel through huge junction boxes and get rerouted to different parts of the plant. You gotta pick up where you left off, and hopefully you're not losing any resistance while that's happening. Okay, so I had an open circuit. If I reset my network right now, so as soon as I lifted that wire, and as I was working to swap them around, it saw an open circuit. It's not gonna see the next thing until it's already in fail mode, so it's like, there's nothing else you can do to me right now, these MOVs. So I had to reset it. So now I got a short circuit. And
So it tells you?
And you can
add it.
so I've crossed the wires at that MOV.
Short circuit.
I got a short circuit and I've lost one. Depending on where you put that short circuit in or where you cross the wires, it could easily blind you from seeing an MOV, which is what you got right now.
And
Because,
your port lights are acting up.
yeah. There you go. Okay, so short circuit could be cross wires, okay? Or you have a real short circuit, like I'm shorting to ground or something like that, okay? Alright. So there you have it.
Now, can you have a card that basically does a short by the relay messing up somehow?
Absolutely.
Okay.
Absolutely. Card can do that. A card can do a short circuit. I've never seen a card do an open circuit unless it was hit by some high voltage.
Okay.
That'll do a nice open circuit. But short circuiting, absolutely. The relay doesn't do what you want it to do.
Okay.
Absolutely. You could see a short circuit. And obviously the easiest way to test that is to verify that you're good on either side of the card. So I'd pull, what I would do is, if I had this wire coming from, let's say, the A side of my network, okay? Let's say if I was going over to this MOV, I would simply just pull both wires off, and I would just use one as my test. I'd land one on the A side and reset. Can I see the A? Okay, then I'd move that A wire over to the B, reset, and see if I can see from that side. If I can see from one side and not the other, I know I have one bad relay. I'm not getting into that car from one side or the other. Or you use the pack tester. You got a pack tester?
No.
Yeah, that's part of my stuff in my luggage that didn't make it. Pack tester will allow you to, I'll bring it in, okay? And I also have a little manual on it. The pack tester allows you to simply disconnect these wires from the master station, from the actuator, and plug into the A side, referencing the common, and look for the address. It's like a pocket master station. Go to the B side, test, can I see the address that I'm hooked up to? That's all it really does. Or you can jump on the wires going that way and say, okay, address upstream of this actuator is 24. The address downstream is 23, grabbing on a different piece of cable. It just tells you, all it does is goes out and it looks for an address. Okay? So, okay, reset. And there you have it. Everything is back and happy again. Okay? So, doesn't matter if you have 50 actuators, this concept is the same. And you're always going to be dealing with a sum of 2 actuators at any given time. Okay? And your hope would be is that the 2 actuators that you're working on are next door neighbors. But guess what? That's not always going to be the case. Okay? It's not, they're not always going to be next door neighbors. So you got to start thinking, if they were like separated by 5 actuators in between, okay? Do you think that actuator number 4 and actuator number, let's say 9, do you think they're in collusion and said like, you know what, we're gonna screw these guys in the middle up, okay? No, it's basically just saying that right in the center of that situation where there is an island of missing actuators, it's saying that in the center of that problem, right there, the loop cannot complete itself getting closer to the source of the problem. So in other words, this is as far as a loop can go and stay online. I can talk to these many actuators really good. I can talk to this many actuators really good. If I get any closer, you can't rely on my communication. So it steps back. So it might have left you with an island of 5 actuators. The problem is on the island, guaranteed. The problem is going to be on the island, but the good thing is, if you have 50 actuators, you only got 5 actuators that you need to kind of go through to figure out what's going on. So what I do is I start with the bypass wire from actuator 5 to actuator 9. I just string that right along the floor from the B side of that one to the A side of that one. Reset. Oh, everything's fine. Okay. Start bringing them in one at a time until you're standing on right on top of the problem. You're done. This diagnostics allows you to cut out steps in your troubleshooting. It allows you to put together a game plan. You guys go to the master station, go to the web browser, have your drawings, and look at everything. Look at what you have going on, and then put together a game plan to go out there and go find it.
Yeah, it's a map.
Yeah.
Basically, you're mapping your actuators.
Yeah. So that's that. So do you guys have any questions on this, on the web browser itself?
Is there a demo, one that you can go on and just kind of work through? It's like without actually hooking up to the...
Like a demo?
Well, basically, you can go through and just move around and select stuff on and off, or so you're not hooked up to a P3, a simulator, that you're not hooked up to a P3.
No, there isn't. It'd probably be real easy to make one, but...
Because you don't see these web pages unless you're hooked to a P3.
Oh, that's right.
To go through and simulate.
Right. Well, I'm sure there'd be an easy way to simulate it, but at the same time, I just have this feeling that if I'm training you on the real stuff, you know what I mean?
Yeah.
Because it's the touch and the feel sometimes. It's the connections. Everything that I'm doing right here, it's the same exact thing you have to do in the field. Okay? These are the same actuators you have in the field. This is the same terminal block you have in the field. Okay? All of this is what you're going to deal with in the field, for real. So I feel simulators are good in a sense because it gets you to go through the motions and everything like that. Mm-hmm. But I guess for me, it's that muscle memory of dealing with the real stuff that's kind of where I'm at, with it. But yeah, we can create a simulation where I could sit here and like watch this. I can create, but you want to see the real thing happening. So there you go. So I don't know. What else would you guys like to cover, or would you like me to expand on anything?
Where exactly is the card?
Oh, let's go on to the next step. Let's open the actuator so you guys can see the actual packscan card. Very good question. Yeah. There you go. Oh, and I can show you some other little shortcuts. Once you're in the electronics compartment of the actuator, okay? Remember I said stuff about being able to, you have to have the actuator off the network in order to give it an address? There's an easy way to take the actuator off the network once you're inside here.
Take the ribbon part.
You can actually create you can shunt or bypass this actuator on the loop, and just, you'll be running right through it, and you wouldn't have to take one wire off the terminals back here. That's only if you're in the event you're changing a board or something like that. Makes it a little bit easier. Now you can address the actuator, and you don't have to take it off the loop. Yep.
Yeah, because you create a vacuum and you try pulling it. I've done it before.
Actually, I drilled a hole in this battery cap right here, so that's why I didn't give you too much.
No, it wasn't too bad. Okay, guys.
Come on up.
Okay, here's your card. That's your network card. And if you don't have network, it also, there's a card that looks like it's a CPT, it's your 4 to 20. But this will be this is basically your network card. You got your communications. Like right here. Power, and the communication, and then there's this, that connects. But that's basically, you undo this. That one right there.
And
your power.
That's your communication and power?
No, this is your communication.
Communication, yeah.
Your
Where's
power is
power?
this one right here.
Which
Okay.
Yeah,
So-
put
This
it-
one?
Hold on.
And that one.
Yeah. So the only ones okay, obviously all these are going to need to come off, okay, but 24 volts DC, that
Okay,
powers
that's
up the
power.
board.
Okay.
That's this, okay? And this goes back to your terminal block. All right, so when I was saying bypass the network, if I wanted to bypass this network and shunt it together, and so I have loopbacks off, I would get a paper clip
Oh,
and I would jumper these two pins together and reset my loop, and I'll have loopbacks off. This guy is completely isolated from the network. I don't have to be in here messing with these wires, and I can readdress this card, put everything back in it, and then take it out and replug it, and you're good. So that's just a little trick. Save a little bit of a time saver. The more you got to keep going in here messing with wires, you're just increasing the chances of rolling them. Because I'll tell you, most places don't have these labeled unless you are marking things before you take it out, or snap a picture of it or something before you take the wires out.
well, good electrician do that.
Yeah. That's where your card resides. And if it's communicating properly, I'm going to go ahead and put power on it after you snap that back in. A visual inspection for communication. You look on this card, there's an LED that would be flashing if it's receiving comms from the master station.
Close limit. Okay.
All right, so you see right there in the center of the card? See the LED
Is
flashing?
that red one? Yeah.
Okay,
Yeah.
now, granted, this guy may not be on the loop right now, but it's still sensing communication going through it. Okay? Because this guy's completely isolated, I would have to reset the loop and bring him back, so we can bring him back into the fold. Okay, so that's what the card looks like. One thing you're gonna need is one of these, what do they call those? The security type hex. It's an M4 Torx security Torx
It's like a
screw.
T20, it's like a T26.
Oh, not this one. Oh, no, these don't have the security. Yeah, these are just, I think those are T4.
Yeah, there's like a
T4.
T
Yeah.
numbers.
Yeah.
different sizes.
Yeah. Yeah, they used to use those damn security ones a while back.
Yeah.
And,
See
you
the
know,
LED? No, it's here.
What's the purpose?
Come from the top.
yeah, yeah. Other than, that guy doesn't have it in his toolkit, you know what I mean? There you have it.
So, but if you guys, if you can, basically just undo this, keep it powered up, change it with the PDA, or you can use the, your little remote, plug it back in, you're good to go. You don't need to go in here and undo it. Now, you gotta make sure that it doesn't drop your system down when you guys unplug. You know, it may sense something and then drop your system out, so you gotta make sure your operators are letting you do whatever.
Yeah, I mean, for us, you know, walking into a pacscan system that, you know, we may or may not have commissioned, okay? And then we don't know how, you know, how touchy the system could be, okay? So when I say a touchy system, instead of me being able to just simply lift a wire off an actuator and it goes in a loop back, and that actuator itself and its next door neighbor going to loop back, I remove one wire and poosh, I've lost half of the loop. It's like, well, what's that all about? Okay. That's usually a function of inadequate loop current. In other words, when I disconnect, where's that little tweaker screwdriver? Oh, it's in my pocket. Okay. Okay. When I disconnect any side of this network, okay, so let's just say I'm going to take the A side completely out. Okay. I'm actually taking it out. Okay, I've just disconnected my A side. Okay. The B side needs to be able to stand on its own and power through and see the whole loop. Okay? So if I reset this loop, when I reset the loop with only the B side connected by itself, and if I had 50 actuators, I should have 50 actuators only on the B side. I shouldn't have 10 actuators. I shouldn't have 12. I should have 50, okay? And that's if I'm seeing something less than every actuator on the loop, usually my loop current is too low. And then you start to raise the loop current, and next thing you know, you're picking up 1, 2 more MOVs, 3, 4 more MOVs, until you get to the point where you're seeing everybody. Now, that means your B side should be able to stand on its own, and the A side should be able to stand alone. So, like when I go back in here now, the only thing that can be communicating would be my B side, and loop backs off. So I got a loop back. I can only see, in this case, I can only see my, yeah, from side B, I can only see 1 MOV. So that would usually be telling me that something's screwed up with my wiring, or better yet, I don't have enough current to even get to the next MOV all by myself, you know, on the B side, okay? So that would be an indicator of an issue. That would tell me that I need to have enough current to get through, or maybe there's some other condition that's causing that to take place. But if you have 2 MOVs on the loop, okay, or 20 MOVs on the loop, each side shall be able to see it, see everything, okay? So this is the problem when I say like one of those touchy systems, where if I break the loop in one location and all of a sudden I lose all of these MOVs, well, that means that loopback's not working the way it's supposed to, because one of those sides can't power.
You have enough voltage.
I don't have enough voltage to power everything. So that's how it happens. That's what I call a touchy system. And that's where people are like, I don't know, we don't want you guys working on the system because every time we touch these things, something crashes. Well, that's because it wasn't set up properly. You know what I mean? Those are some of the checks that you do before you walk away to make sure that either side, I mean, because look, you know it's two different current sources because I got two different potentiometers that allow me to tune. Okay? So these are two unique, so don't just tune the A side and say, okay, we're good, and walk away from it. You gotta tune the B side also.
Tune it with the other side disconnected?
Yes, yes, you do.
Okay.
Yeah, you
Use a scope.
Yep, and you should be using a scope. And you should also be you should also be looking to set it to a voltage or current based on
I'm not gonna give you.
measured resistance. So in other words, I'm gonna power down, once I get everything wired up, I'm gonna power down everything on the loop.
Check resistance.
I'm gonna check my overall resistance. I'm gonna check my overall capacitance. And I'm gonna use that, I'm gonna run it through a calculation by however many MOVs divided by loop resistance times some factor, and it's gonna come up with a number. And that's gonna be my ideal voltage for the loop, okay? And that's when I hook my scope up, and I'm sitting here tweaking on this potentiometer, I'm watching it, and it's like, that's my ideal voltage. And I might give it a little extra turn just in case, okay? And I'm gonna tune the A side and the B side.
For the same.
Okay, this is during the installation?
This is during the installation phase, but
Like you check this way and then the other way?
Exactly.
And it has to work?
yes, because a lot of times, people just hook this thing up and they reset the loop and the A side works beautifully. And you see everything, and you have no loop backs on. That doesn't mean that the B side can communicate all the way through. You know what I mean? So it's usually the B side that's always low on voltage, and you break it anywhere and you lost a whole
And
bunch.
if you have
of
it too high in voltage, if I'm not mistaken, if it's too high in voltage, it basically can cause problems too, because it, like the,
You start to see shadows. If there's voltage is too high, here's your indicator that your voltage is too high. You only got 50 MOVs on the loop.
See more?
Yeah, you start
No,
seeing
wow,
75.
yeah.
It's like
51 or
75. Yeah, duplicate address.
So
Yeah.
you start decreasing until you see the right amount.
Yeah, well, yeah, for the most part. Okay, and then there's the before we got smart and started using scopes to tune the loop. Okay, there's the old-fashioned way. Okay, turn the potentiometers all the way down, reset the loop. I see 1. Tune it a little bit, reset the loop. I see 4.
It's a long process.
Yeah. And then you can start getting ambitious. Turn it 3-4 times. Okay, I'm seeing 45. Turn it a little bit more until you see just the right amount of MOVs, and then you give it a couple of extra turns for good measure, and you walk away from it. All right? And then you do the same thing on the B side. Okay, I've really kind of almost done the same thing. You can either pre-calculate it and have data, or you can just freestyle.
At that point, your lights should be about the same intensity also,
Yes.
right? So if you have one dim one.
If you have one that's dim, that almost tells me that just you get on that pot and just give it a little until that light brightens up a little bit, and you're done. What happened was you're tuning the A side and the B side, and I like to give it the couple of extra turns or a turn or extra for good luck. Probably one of them didn't get the extra turn for good luck. That's all it was. That's all that was, probably. So, yeah, that's
Or the
pretty much it.
driver drifted a little bit, or something changed in the.
Something changed because
you get more resistance in the
if,
line somehow.
if it
water
was,
goes in.
well, yeah, well, that's the thing. If the voltage they tuned it to was based on measured readings, it was based on the measured readings at that point in time, right? So, yeah, maybe there's another condition that causes the capacitance to go up. So all your readings are out the door. So it's almost like maybe you want to, is it ever possible to take readings when you have a full system online? We're not going to reposition any valve, but we got everything running full bore, okay? We're just going to power down some stuff, and we're going to take some readings. But the minute you see an actuator offline, or you're not getting feedback reported, then it's going to throw the system offline. Unless you've configured it to hold last value. the master station to hold last value. Then you could probably do a test like that. But that's
So
another thing.
annually, when we shut the plant down, we should probably come in and take loop readings
Wouldn't be a bad idea. Wouldn't be a bad idea.
to keep a log of.
Keep a log,
if it's
because
close
it'd
to
be,
where it was originally.
exactly, because if it's changing, then there's
Something's going on.
there's really something going on. And it's just a problem that's gonna end up,
Now, will that generally be a wiring problem,
yes.
change, or?
I'll tell you honestly, what I've always seen, it's always like a seasonal thing, okay? We had a bunch of heavy rain, end of last year, beginning of this year, we had some heavy rains, just for like a week, a period of a week up in the Bay Area, San Francisco Bay Area. And that's all it took for me to start getting phone calls from like 2 different pacscan customers. You know what I mean? And what did we find? We found water in conduits. We found water in conduits. We found water inside the terminal blocks. Okay, so like I said, it's seasonal. During the summer, you're not going to see it. In the rainy season, when the one-off rain starts coming in, then you see it. But then now you know what it is, though, right? Because water shouldn't be getting into equipment. Period.
Are you finding it in a section that's just cable with no terminations that's underwater? Well, because that can change your capacitance and all that in cable.
What I've seen is it's usually coming through. Okay, you'll have like some conduit coming down a wall. Okay, coming over to the actuator and some flex, and you got a nice little service loop right down it, right before it goes up into the actuator. I see water coming in a conduit here and just working its way through. And it's usually a conduit that's up, coming down a wall, usually,
But it's getting to a termination.
It's getting to a termination point, and it's probably where it junctions off and it's going, this elbow right here, whatever it is. Water's just getting in, coming down the wall and just getting in that way, just slowly filling it up.
Cable comes into the water,
Mhm.
the capacitance, everything changes right at that point.
Mhm.
And then again, when it comes out,
Yep.
there's another change. I didn't know if a solid piece of cable was submerged, if that would be enough to throw. If you've ever seen that, I realize if it gets in termination points.
Right.
The
No,
motions
I mean,
don't play that.
if you get a section of conduit filled with water, yeah, you're raising the capacitance right on that side of the loop, which overall, it's gonna raise the overall loop capacitance, right?
Right.
So, yeah, that's where another idea is, if we think we have an issue like that, you can install drains in the low spots of your conduit, where your conduit runs.
We started doing that out
Yeah.
here.
Yeah, I mean, I think it's a great idea.
Yeah, breather drains.
Yeah, install drains at those low points, and then you just never run into the issue. You'll never, unless the drains get plugged up. So that's just another whole maintenance thing. But still, I mean, that'll save a system in itself. So, yeah. So. Anything else?
Is there any
Packscan-ish?
maintenance that needs to be done?
Hmm?
Is there any maintenance that needs to be done by these guys on the equipment, or?
In regular
On a PACScan system, other than, like if you guys are gonna go through a shutdown, I would definitely just check your resistance and stuff like that. I mean, because it shouldn't change from time to time. It shouldn't change. If all things being the same, it should never
Those
change.
cards on the actual PACScan unit,
Mhm.
are they removable?
Yeah.
So how do they disconnect? How do those come apart?
So you look up here, look up top, look over the little very tiny, and these should have come in your kit with the master stations. Very tiny, small little Allen screw right here.
Yeah.
So those come off.
And it's just plugged in right there?
Yeah, just so literally there's a little. Let me see if any of these are.
Go from the bottom then.
It's like it just pivots off.
Yeah, it pivots off, so it feeds into these. You got two little tabs.
Down there?
Yeah, and then just lean it in. You just want to make sure that you got proper alignment here.
Okay.
You got 120 volts hanging out behind this, so you want to make sure that those 3 pins are aligned. before you sit it down. Also, when you power this thing down, you power down a master station. Always wait about 30 seconds before you start doing any kind of board swappage, because your capacitors are still charged. Still charged. And yeah, I think it was something that we learned, you know, because yeah, you don't want to, on the 2E, that was one thing about the 2E master station, it seemed like you could almost freaking hot swap those things. But you know, not recommended, but it was that rugged, where there were people that would just literally pull those power supply modules up, plug it back in. I mean, hot swapping things, but it's like, that's not recommended, but people would do it, okay? And equipment survived. I wouldn't be trying it with these bad boys here. The electronics on these are a lot smaller and a lot more fragile. Yeah, exactly. It's not like you'd have a big resistor. You see a blown out resistor in a 2E master station, you could probably desolder that and put another one in there. It's that big, you know what I mean? This is all microelectronics. I would let these capacitors discharge nicely. You know, wait about 30 seconds, and then start moving stuff around. Other than that, careful, because it's still got a charge on it.
On the pacscan card, can you get each board separately, or does it come as a unit?
Yeah. All
If so, what board
This
does
is the
what?
pacscan
that one right
card.
there, that little half moon shaped
And
board.
there's two screws that basically screw to this board.
Okay. So what's, is
And
the
then this is your
motherboard?
main board, the main motherboard, basically.
Yeah, that's our main PCB. Okay. Here's power. Yeah, that's power to the whole board right there. Okay. So you'll notice on the back of this board, okay, this is your pacscan card. And that's the guy that's not causing all the trouble, but that's what all the hoopla is about. Okay. Good thing about these actuators, and even though it looks like, look at all these plugs on the back. I better take a picture of that before I go taking it apart, right?
All different sizes?
Everything's a different size and a different type of plug.
That's pretty cool.
Yeah, you cannot,
Like
you can't even screw it up if you wanted to. I mean, I've seen people try.
It's still a good thing to take a picture,
Yeah,
but
take a-
still,
Yeah.
it's pretty hard. And plus, you don't have to take all of them off sometimes, depending on what you're working on.
Right. So if it's a COM problem, it's probably gonna be the pacscan card.
Yeah.
But if you're you don't have loop back going on and all that, but you're having an operation problem,
Yeah.
it's probably gonna be the motherboard.
Could be.
The battery?
Could be.
A fuse, the battery.
Now, here's another thing, okay? If you ever walk by one of these actuators and you see a 24-volt loss alarm on it, okay? That means your pacscan card just went out too, okay? Because our 24-volt power supply is powering up that pacscan card, okay? Now, in most actuators, 24 volts auxiliary power, that's available for you guys to use for control or whatever. They may or may not be used, because your PLC might be supplying that control power, right? Maybe loop power and things or whatever. Who cares about the actuator's power? But when it comes to pacscan, or any of our bus options, other than foundation field bus, and which is more loop powered anyway. It's getting its power and its signal across the loop. pacscan is getting its 24 volts from our step-down transformer, so our power supply. So, if you were to walk up to an actuator and you see right across the bottom 24-volt loss, guaranteed you're not communicating with that actuator either, and it's probably in COM fail at the master station. So that's just another thing to look at, okay? Your power supply, keep an eye on the power supplies also. Not a bigger problem on these, but, just something to know.
It's okay, we'll call you.
Yeah. Say, I got this 24-volt loss alarm and I can't get it back online. I said, it probably won't go back online.
Tried to reset it, didn't reset.
But the actuator's powered up, so it's like, well, now what? And then you go swapping cards out, and that has nothing to do with it. It's just that it's not getting 24 volts. And also, make sure you always plug in 24 volts when you reinstall a card.
Yeah, the connect, you know, sometimes you'll see COM fail too, is because this has worked its way off. Somebody had worked on something and they didn't put it back on.
Yeah.
Or it just got loose once they put it on there, the wires, it came loose, and then you got an issue that way.
Can you test right there?
This is the 24 you
I
said,
put a
right?
couple pins in there and like,
Yeah.
This one here?
This one
That's right there.
This one here's 24.
And this one supply for.
That goes to here. That's
but
for the
that
main
one-
board.
for the main-
This is the main board power.
New cards readily available.
And,
Oh,
you know,
yeah.
and if your power mod goes out, you guys,
Yeah, those are usually
they're
stock.
pretty basic to
on the
change
shelf,
out.
Easy to get.
You know, you've got 4 bolts that you undo the screws.
I got this whole deal here?
Yeah, that,
Oh.
but I mean, eventually you guys
Yeah.
can do your own, shouldn't say that, but.
Well, I mean,
but,
that's another class.
That's another
That's another
class.
class.
You know,
That's another class,
Yeah.
Which is learning how to,
cause like this, cause look,
and I think it'd be a good one,
these come off.
tearing these things apart. Like a tear down and rebuild,
There's like 2
troubleshooting the
other ones that come
actuator
off here.
itself. I mean, pacscan is one.
And you basically, this whole piece comes off, and you just have to, and then there's a wire in the back, a ribbon. There, and then basically, cause most of the
See how
time,
we're getting power distribution.
because
and
this is what's
everything,
gonna
yeah,
be, this is what's gonna get you your 24 volts, is like if you get a 24 power failure, or, you know, you blow a fuse or something, it's basically this unit here. If your screen's dead, most likely it's just has gone bad, and then you just change it out and put it back in.
huh?
It's,
More winding going on.
But
but,
if it's only 24 volts, we'll be.
yeah, but you're gonna change the whole thing, you don't change
This
just
is
the.
one
Oh, okay.
complete,
One
Yeah.
volt.
It'd be,
this is just a choke.
it would be really nice.
Yeah, it's like I call it a donut,
If
but
we
it's
could.
what's this,
it
it
a
goes
coil
from,
or-
it's
It's a
a
toroidal.
toroidal.
So, yeah, so basically, I mean, on the back of that motor control board, you got that because these actuators, no matter what the voltage is, it's a 24 volt DC motor. So, we're basically, yeah, 24 volt
Even if-
DC motor. Even if you have a 550 volt three-phase unit, it's a 24 volt DC motor.
Step it down this way.
We step it down a little bit to
Yeah,
this
that's
coil
what he
right
was
here.
talking about, the 480 and the.
Yeah, but you know what?
Uh-huh.
If you ever undo this, it's a bear getting it back on.
Yeah, that's why you don't mess, you just.
Yeah. You've actually, okay, yeah. Yeah,
Yeah, so-
that could be an issue.
I got it back on, but it
Well, the screw back kept on
Yeah.
backing up on
it
you.
kept backing up. on me.
And these are always, if you ever think of
Don't
the
worry,
group,
we've
U2,
all done it.
U is always gonna be wire number 2 that goes on. So when you have, you know, basically that's how I remembered, U2, and then it's gonna be.
U2.
And then, you know, it can be different on these, there's different taps, but it's generally, I believe it was X.
Uh-oh. You can always look at this one.
Next training class is gonna be all messed up.
What's the, here, hold on, we'll see.
I don't even remember what it is.
It's gonna be,
All I know is U is 2, and then 3.
U2.
Yep, that's how you remember it. U2.
yeah.
Seriously.
That's how I just like the group U2, so it's easy to, but let me get this books, I should have it on the packscan, should give us our, unless it's not gonna be the same.
For 120 volts.
It's gonna be a 1, so X is 100, Y is 110, Z is 120. So,
Doesn't matter.
Z,
Yeah, put it on 120. Unless they have 115 coming out of the walls here.
well, it's 96 to 144,
Yeah.
88 to 132, or 80 to 120, so,
The only difference in any of those settings, as far as, because you're still within the same swing of voltage, the difference would be our auxiliary 24 volts that we give you guys for control if you needed it, can go from, let's say, 24 volts on up to a right 30 volts, depending on how you tap that transformer. So, just like anything else, you know, the input,
but like,
yeah.
like, see, these over
Ratio
here, you have a
stays
ground,
the
and then you have the one coming from this fuse. Sometimes if you guys, if there's a fuse here, when you guys have this other class, or hopefully, then you can get a little more familiar with it, but there's basically, you undo these 2, and then this whole thing comes out.
Well,
You
I
know,
think that, you and Izzy just would plan, you know, the input, but like,
Yeah.
I think that you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like, you and Izzy just would plan, you know, the input, but like bring in some demos in here, and you guys just,
Yeah,
these guys the ones over, just.
Yeah.
What I'll do is I'll send you some degreased, and, you know, oilless.
Yeah.
Demos, and just stop by one day and, give these guys a tear down course.
And how long is that?
It can be like 4 hours, or 4 hours. I mean, nothing.
Because, you know,
Nothing major.
I can't see it being, yeah, too terribly long.
no,
It's
I
just
mean,
like, yeah.
eventually, you guys have, you know, on your own a little bit, you know, as far as you guys can do your own maintenance, or you can kind of look at stuff, it's just one of those things where you try to be, but you always remember these go inside to put the card, and then you just put it back on. Yeah, and what we end up doing is twisting them sometimes, so the wires stay out of the way, but this one isn't too bad. Go on the outside. And
And then getting the cap back on is the bear too.
we can test to make sure we got our wires together.
In the air that's in there, you're like,
Test.
This is smoking.
You can look at the front, yeah. You can look at the front and there'll be like a little air, because you don't have the
Don't let
cap.
the smoke out.
Any special tools when you tear down?
You're gonna need a set of metric Allen wrenches.
Ellen range, yeah.
T-handle.
And, yeah, metric T-handle Allen wrenches, and
Like I'm about.
I would use a-
Special little tools that
I
you
like,
have to use.
I like these type of screwdrivers right here.
Hold these screwdrivers?
Yep. Yes, these are the best as far as wiring into these terminal blocks back here, all right? Because you have like a flat washer and you got
Yeah, to hold
a
it.
lock washer.
This
This
You
is,
hold it.
yeah, you definitely want to have something like
Put it up
this,
a little bit like this.
and
Okay.
pretty much that's
Just,
it.
just because it keeps it out of the way, because it can get in front of the display.
you guys have a kit or anything?
Usually.
We do have a kit. We do have a kit. Actually,
If you can put it all the way up.
Yeah.
these two came out of a kit.
Oh, I think it's the
So
old way.
it's a
Well,
toolkit that
put it
comes
all the
with
way
a
up,
bunch
pretty
of
much
these,
all
all
the way up
different
to it.
sizes.
Okay, yeah.
And
And
a couple of these, like two different sizes of these.
Then,
You help with the,
So, it's a kit that we sell,
if you don't,
that they just mass produce them, and, you know, if somebody wants,
oh, I see what you said.
like
the other
like
thing
a
is-
rebuild kit
No,
for one of our actuators, they'll sell you all the seals and
but it's
bearings
hard because
and
it's,
the tools.
it's not mounted. When
Yeah.
It
it's
should
mounted.
actually come with the
Can
brand
we
new
get a, can we
actuator.
get a set after we?
Yeah, no, it's important when we are seeing about it.
I am
See,
willing
you
to
can
get you
feel-
guys squared away
when
on
you-
some
if you
things.
can
I'm
push
even
it all the way
offering to
up
give
and
you
get it
guys
to
some
do this,
free
you know
training here
there's no
too
wires
on
in
some of
there.
this
Yeah.
stuff too.
If it comes in and it,
Okay.
there's a
But
gap,
yeah, I can get you guys
push,
some,
and you,
a couple
when
of
you
these
tighten it
toolkits.
up,
I
you're
got a
gonna,
bunch of them in my shop.
you're gonna, you're gonna see some smoke when you,
Nice to have one.
Yeah, and then you're gonna see the smoke.
I will get you a couple of toolkits, and let me put that in my,
You're on tape.
yeah. Yeah, I know, huh? Dang it.
Zoom in on it today.
Oh, man.
now Fred, you're not gonna be able to, you're not gonna be able to back out of that.
I remember he said free training, free kits, and he something about a few actuators to boot.
That was part of the package.
He no longer works for the company.
Oh, man.
But
Hey,
yeah,
man,
once
I'm-
you kind of mess with the electronics in it, they're actually pretty straightforward.
Tesla.
And in the back, there's a motor controller, and that comes out, and it's all, you know, once you look at it,
All right.
you maybe have another guy watching you, it helps. Okay, we're good.
We're waiting for the freebies now.
Hey, you guys got donuts this morning.
That was appreciated, thank you.
Yes, very.
All right, I gotta, you know what? I think Mo's coming tomorrow, so I'm gonna tell him to bring donuts, bagels, breakfast sandwiches,
Oh, you
and the
do us
works.
like
No,